Hi everyone, welcome to goclasses. In this lecture, we will continue our discussion of non-regular languages. In the previous lecture, we have seen how to find if a language is regular or not. Okay, so in this session, we will continue that discussion. This is part 2, finding if a language is regular or not. Okay. So the part one you can find on the YouTube. On the YouTube, you can search Go classes non-regular, and you can find this part one. You can see in this part one we have seen how to detect if a given language is regular or not with proof. Okay, so you can watch it. Now let's do the recap of the previous lecture. Let's do the recap of the part one. In the part one, what we have seen. So for detection of regular or non-regular language, a language will be given to you and the question will ask you, is it regular, is it non-regular? So I told you what the step one. Step one is you understand the language carefully, because this is very important. First you understand the language, then you find out whether it is regular or not. Okay, so remember, first you understand which strings are in the language and which strings are not in the language clearly. Okay, so first you understand the language, then some points I told you. The first point, that is every finite language is regular. If the language is finite, then definitely it is regular. Okay, and remember, infinite language may or may not be regular. We have seen, for example, this sigma star, this is an infinite language, but this is regular. Okay, also we have seen, for example, a power n, b power n, where n is greater than equal to 0. This language is non-regular. So you can see that infinite language may be regular or may not be regular. Okay, so this is what we are saying, that infinite language may or may not be regular, but finite language is definitely regular. Okay, another point, that is, if for the language L you can create DFA or NFA or regular expression, then definitely the language is regular. Okay, also the complement of regular language is regular. So if you have a regular language, then the complement of that language, that is also regular. Also, union of regular languages is regular. Intersection, union, set difference, symmetric difference, concatenation, clean star of regular languages is regular. So if L is regular, then L star is also regular. Okay, if L comma R are regular, these two languages, if they are regular, then their union is also regular, their intersection is also regular, their difference is also regular, their symmetric difference is also regular, their concatenation is also regular. Okay, now let's see when the language will become non-regular. When can I say that language will be non-regular? So I told you that in the language L, if there is comparison or matching or counting, then most probably the language is non-regular. Okay, in the language, if you have comparison or matching or counting, then most probably the language is non-regular. Okay, and I told you that if you can find infinite possibilities of comparison, then the language will be definitely non-regular. Okay, so this is important point, that if you can find infinite possibilities of comparison, then the language is definitely non-regular. Okay, now in the previous lecture I told you what the formal method to prove if a language is non-regular. A language L that is given to you and the question is asking you to prove that it is non-regular, so what the formal method? Okay, we have already seen the informal method. This is the informal method, that if there is infinite possibilities of comparison, then the language is non-regular. Okay, yes or no? If there is infinite possibility of matching, then also the language is non-regular. But what is the formal method to prove that a language is non-regular? I told you this method we have already seen in the previous lecture for many examples. Okay, I told you that if the language has some comparison or matching, then most probably the language is non-regular. Okay, now what we do, we find the infinite possibilities of comparison. Okay, in the language we find the infinite possibilities of comparison or infinite possibilities of matching. Then I told you what are the method to prove that the language is non-regular. What you need to do, from these infinite possibilities of comparison, you need to create a infinite set of strings. Okay, so very simple point, these infinite possibilities of comparisons that you have, from these infinite possibilities of comparison, what you do, you create this infinite set S. Okay, we create this infinite set S. Remember, infinite set S we create. Okay, so very simple, we create infinite set S of strings such that whatever two string you take from this set S, whatever two strings from set S you take, okay, if they go to same state in any DFA, in any DFA, if two strings of this set S they go to same state, then problem will happen. Hence, I can say that the language is non-regular. Yes or no? Okay. So this is the idea. Is this point clear? Please tell me. So this method we have already seen in the previous lecture. Okay. So if you want to prove that the language is non-regular, then what you need to do? Remember, if there is comparison, if there is matching, then most probably the language is non-regular. Okay. Now you create the infinite possibilities of comparison. From these infinite possibilities of comparison, what you do? You create infinite set S of strings. Yes or no? What we do? We create infinite set S of strings such that whatever two string you take from this set S, from this set S, whatever two string, any two string you take, whatever you want, okay, if they go to same state of any DFA, then the problem will happen. Hence, I can say that the language is non-regular. This method we have seen in the previous lecture for many examples. A lot of examples, a lot of languages we have seen, and we have proven that those languages are non-regular. Okay. Now, so this method we have already seen. Now let's move on. Now let's see this language of balanced parenthesis. So let's understand this language and then we will see whether it is regular or not. Okay. So let's see this language of balanced parenthesis. First of all, what is balanced parenthesis? You already understand your alphabet is basically this is alphabet. In the alphabet, we have open parenthesis, we have close parenthesis. Okay. So what will be the balanced parenthesis? The balanced parenthesis string will be like this. For example, this is a balanced parenthesis. Yes or no? Every open bracket has a corresponding close bracket. Okay, very simple. Okay, for example, you can see this is also balanced parenthesis. For example, this is also balanced parenthesis. Yes or no? All these are balanced parenthesis. Do you agree? For example, this is another balanced parenthesis. Yes, correct. Okay, another example is like this. This is another balanced parenthesis. Okay, so very simple. Empty string, that is also balanced parenthesis. There is no open bracket, there is no close bracket. Okay, so like this. So there are many balanced parentheses we can create. Okay, and what are not balanced? For example, you can see this string, this is not balanced. Okay, so let me write it in red. So you can see this string, this is not balanced parenthesis. Okay, what is another not balanced parenthesis? For example, you can see if I give you this type of string, this is not balanced. Yes or no? Is this clear? Okay, so very simple point. For example, if I give you this string, this is also not balanced. Okay, so this is the idea. I hope you understood. Okay, so what is the balanced parenthesis? This language we have already seen. So you can see this is balanced parenthesis. Here you can see there are three open bracket, there are three close bracket. Okay, for every open bracket there is a close bracket, right? Okay, so you can easily see this is also balanced parenthesis. For every open bracket there is a close bracket. Okay, here also for every open bracket there is a close bracket. Okay, so all these are basically examples of balanced parenthesis. Okay, now let's see the definition of balanced parenthesis. We have seen the examples, but what is the definition? If someone asks you to define balanced parenthesis, okay, will you give the examples? See, we have seen the examples, but you tell me the definition of balanced parenthesis. First you tell me, can I say this is balanced parenthesis? See, if you say that, sir, every open bracket has a corresponding close bracket, then this also should be balanced. Yes or no? Here also every open bracket has a corresponding close bracket. So tell me, can I say this is balanced? No, this is not balanced parenthesis. Yes or no? Okay, so can you define the balanced parenthesis? Tell me what is the definition of balanced parenthesis without examples, without giving examples. You tell me what is the definition. Can you define the balanced parenthesis? Yes, of course. First of all, you can notice in the balanced parenthesis what should happen. If you have a string, let's assume this is your string. In this string, you have balanced parenthesis. Okay, for example, let's assume you have this type of situation that your balanced parenthesis here. Okay, so this is your balanced parenthesis. So first of all, can I say that number of open brackets should be equal to number of close bracket? Yes or no? That condition is there. Okay, this condition I can say that number of open bracket is equal to number of close bracket. Agree? Yes or no? This is the first point. But tell me, is it enough? Is it enough? Can I say number of open bracket equal to number of close bracket? Is it enough? No, it is not enough. For example, this is not balanced. Yes or no? Okay, so what should happen? What is the second thing that should happen? This should happen that, remember, see, in the balanced parenthesis, let's assume you have this string W, which is the balanced parenthesis. In this balanced parenthesis, you tell me, like this is your string, which is balanced parenthesis. Okay, if you see at any point, for example, let's assume you are standing here. Okay, and you tell me at this point, if you see a right parenthesis, then tell me for this right parenthesis, where will be the left parenthesis? For this right parenthesis, the corresponding left parenthesis, where it will be? Can I say it will be the corresponding left parenthesis? Please tell me. For this closing parenthesis, what will be the corresponding open parenthesis, where it will be? On the left or on the right? Tell me. Very simple question I'm asking. Okay, so remember, you are standing here. You are standing here. Now you tell me for this closed parenthesis, where will be the corresponding open parenthesis? Will it be here or will it be on the left or on the right? On the left. Yes or no? Definitely on the left. So I can say for this closed parenthesis, remember, for this closed parenthesis, the corresponding open parenthesis, where it will be? The corresponding open parenthesis will be on the left. Okay, yes or no? The corresponding on left, I can say on left we will find the corresponding open parenthesis. Agree? So this is the simple point. So from here, can I say, just understand this point, can I say that at any time if you stay, okay, in this string, at any time if you see, okay, in this string, at any time, at this time, for example, if you stay, then can I say that in this here, can I say that number of open parentheses will be at least as many as number of closed parentheses? Yes or no? Number of open parentheses, they will be at least as many as number of closed parentheses. Do you agree? I am saying the number of left parentheses, for example, because if you have a closed parenthesis, please understand, see here you can have open parenthesis, no problem. Okay, but if you have a closed parenthesis, let's assume there is a closed parenthesis, or I can call it right parenthesis. Okay, this I can call it right parenthesis, and this I can call it left parenthesis. Okay, or this I can call it closed, this I can call it closed, and this I can call it open. Okay, so you can see if there is closed parenthesis, then definitely there will be open parenthesis somewhere. Yes or no? But there can be extra open parenthesis. Okay, because maybe for these open parenthesis, the closed parenthesis can be somewhere here. Okay, do you agree with me? Please tell me. Okay, so this is the simple point. I hope you understood. Okay, so this is the idea that, okay, so let's see the idea. The idea is basically in the balanced parenthesis, what will happen? The number of open parenthesis equal to number of closed parenthesis, and remember, in every prefix, what will happen? Tell me. In every prefix, what you can say? Let me know. In every prefix, what will happen? The number of left parenthesis will be greater than or equal to the number of right parenthesis. Yes or no? Is this point clear? This is the definition. Let me tell you, this is the formal definition of balanced parenthesis. Is this point clear? You can easily see any any balanced parenthesis you take. For example, you can take this balanced parenthesis. Okay, here also you can see in every prefix. Okay, look at any prefix. For example, consider this balanced parenthesis. This is your balanced parenthesis W. Now in this W, you look at any prefix. For example, consider this prefix. For a moment, consider this prefix. In this prefix, can you notice we have two left parentheses and one right parenthesis? Yes or no? And look at here. Here also we have more left parenthesis and less right parenthesis. Here we have equal. Okay, so this is what I'm saying. Whatever prefix you take, in every prefix, what will happen? Let me know. In every prefix of W, tell me what will happen. In every prefix, whatever prefix you take, in every prefix, what will happen? The number of left parenthesis, that will be greater than or equal to, either equal to or greater than, okay, number of right parenthesis. Yes or no? Is this clear? So remember, this is the definition. This is the formal definition of balanced parenthesis. I hope you understood. In the GATE exam, they can give you the formal definition. Okay, instead of giving you this name, they will not tell you that this is balanced parenthesis. They can give you the definition. Sometimes they can do this. Okay, they will not tell you this word, they will not use this word. Without using this word, what they can do, they can directly give you the formal definition of balanced parenthesis. So remember, this string W, if your alphabet is open parenthesis comma closed parenthesis, okay, let me call it left parenthesis, let me call it left parenthesis, and let me call it right parenthesis. Okay, is this clear? So here I can say that the definition is W is balanced parenthesis. When can I say W is balanced parenthesis? If and only if W is balanced parenthesis, if and only if two things should happen. One and two. Two things should happen. What are those two? The first thing is number of left parenthesis is equal to number of right parenthesis. And the second point, in every prefix, in every prefix of W, in every prefix of W, what should happen? In every prefix, what should happen? In every prefix, I can say that number of left parenthesis is greater than equal to number of right parenthesis. Okay, is this clear? Please tell me. So very simple. Remember, in this W, number of left parenthesis equal to number of right parenthesis in the entire string W. In the entire string W. And in every prefix, what should happen? In every prefix, number of left parenthesis is greater than equal to number of right parenthesis. This is the formal definition. Okay, so I hope this point is clear. So you can easily see this is the definition given to you. Now let's move on. Now let's see this language balanced parenthesis, is this regular or not? The language of balanced parenthesis, can I say this is regular or non-regular? Tell me. Yes, this is non-regular, because here you can notice there is comparison. Okay, and there are infinite possibilities of comparison. For example, if you have one open bracket, there will be one closed bracket. Yes or no? If there is one open bracket, there will be one closed bracket. If there are two open bracket, then there will be two closed bracket. Yes or no? Okay, similarly, remember, if there are three open bracket, there will be three closed bracket. If there are four open bracket, there will be four closed bracket, and so on, and so on. Yes or no? Is this clear? So this is what I'm saying, that there are infinite possibilities of comparison. Do you agree? There is infinite possibilities of comparison. We have infinite possibilities of comparison here, because you can see the open bracket. How many open bracket we can have? Any number of open bracket. If we have one open bracket, then one close bracket should be there. If we have two open bracket, then two close brackets should be there. If we have three open bracket, three close brackets should be there, and so on. If we have 100 open bracket, then 100 close brackets should be there. So very simple, there are infinite possibilities of comparisons. That is the reason I can say that this language is what? This language is non-regular. Okay, of course, if you want to prove it formally, then you can do it. Okay, in the formal proof, tell me which infinite set of strings you will use. Let's see the formal proof. In the formal proof, basically you can consider these infinite possibilities. Yes or no? You can consider these infinite possibilities. Look at these are infinite possibilities. Okay, so these infinite possibilities basically you can use. Okay, so let's see the formal proof for this language balance parenthesis. So the formal proof is like this. Consider this set as, in this set as, what you do, you consider these open bracket. Okay, open bracket 2 times, open bracket 3 times, open bracket 4 times, open bracket 5 times, and so on. Is this an infinite set? Tell me. Remember what I'm doing? I'm considering these infinite possibilities. These infinite possibilities I'm considering. Okay, is this clear? What your DFA, if you assume this language is regular, if you assume this language has a DFA, then your DFA, what it will do on these strings, these are infinite possibilities. Yes or no? Infinite possibilities. So this is what I'm saying, that you take this set as, definitely you can easily see this is an infinite set. This is an infinite set of strings. Correct? Agree? Okay, so now you tell me here, these infinite possibilities we have taken. Now you tell me just simple point. If I assume this language is regular, then this language must have a DFA. Okay, and DFA has finite number of states. Now you tell me, if I assume this language has a DFA, then the DFA, can it go to different states on all these strings? Is it possible that your DFA can go to different states on all these strings? On this string you are going to different state, on this string you are going to different state, on this string you are going to different state, and so on. Is it possible? It is not possible, because if your DFA goes to different states on all these strings, then there are infinite number of strings here. Here we have infinite number of strings, so you need infinite number of states in the DFA. But your DFA has finite number of states. So definitely your DFA cannot go to different states on all these strings. So what should happen? at least on two of them, okay, in this set, at least on two of them, I can say that your DFA will go to same state. Now let me tell you what I will do. I will prove that whatever two strings you take here, you can take, for example, these two strings, you can take these two strings, whatever two strings you take here, if they go to same state in the DFA, then problem will happen. Okay, this is what we will prove. Okay, so whatever two strings you take, read this, whatever two strings from this set as you take, if they go to same state in any DFA, then problem will happen. Okay, so definitely there is no DFA that will recognize this language and the language will be non-regular. Okay, now you can easily prove here, from here you take any two strings. So tell me which two strings should I take? Take any two strings you want. For example, what you can do, okay, from the initial state, this is the initial state, from this initial state, let's assume that these two strings, any two strings you can take from the set S. I am saying that here whatever two strings you take, if they go to same state in any DFA, then problem will happen. Okay, so take any two strings you want. For example, you can take open bracket power 5, open bracket power 2. Okay, consider these two. If they are going to same state, this is your state q1. Now problem will happen. And how the problem will happen? Because now you consider what will happen from this state q1. In this state q1, if this string closed, okay, closed parenthesis power 5, if this string comes, then where you will go? Then what will be this state q? Will it be final or will it be non-final? This is the problem. Now you can notice, if this state, if I make it final, then problem. If I make it non-final, then problem. Are you getting my point? If I make this state final, then also problem. If I make it non-final, then also problem. Because if I make it final, then tell me where is the problem? Just tell me the problem. If I make it final, if this state I make it final, then you can notice that this string is accepted, but this is not balanced parenthesis. Yes or no? Okay, so if I make it final, then this open bracket 2 times and close bracket 5 times, this string is accepted. Yes or no? This string is accepted, but this string should not be accepted. So definitely there is a problem here. Okay, in our DFA there is a problem. If I make it final, then there is a problem. Now if I make it non-final, is there any problem? See, this state q, if I make it final, then there is a problem because this string will be accepted, but actually this string is not in the language. Okay, so if I make it non-final, then is there any problem? Yes, there is problem. This string will be rejected. This string, okay, this string, open bracket power 5, close bracket power 5, this string is rejected, which is another problem. So you can see that this state q, if I make it final, then problem. If I make it non-final, then problem. Whatever I do, there is problem. So can I say our assumed DFA was wrong? Please tell me, let me know. So any DFA you assume, that will be wrong. Okay, so remember, any DFA you assume, that will be wrong. Any DFA that we assume for this language L will be wrong. So this language is non-regular. Okay, is this point clear? So very simple, this language that is non-regular. Okay, understood? Please tell me, let me know. So basically here what we have done, notice, okay, I told you that in this language balanced parenthesis, we have infinite possibilities of comparison, because if you have two open parentheses, then two closed parentheses. If you have four left parentheses, then four right parentheses. If you have 100 left parentheses, then 100 right parentheses, and so on. So there are infinite possibilities of comparison. Then what we have done, we have taken these infinite possibilities of comparison as a infinite set S. Okay, basically what we are seeing that if you assume any DFA for the language L, then what your DFA will do on these strings. Okay, so this set S we have considered. Here you can notice, okay, open bracket power 1, okay, you can see left bracket power 2, left bracket power 3, and so on. So this is an infinite set. Okay, now what we have done, we have proved that if any two of these strings they go to same state in any DFA, whatever DFA you assume, in any DFA, if any two of them, any two, whatever two you select, for example, if you to select these, if you select these, if you select these, see, whatever two you select here, if they go to same state in any DFA, then problem will happen. This is what we have proven. So what should happen? So these strings, they should go to different states in DFA. Yes or no? This and this and this, they should go to different states. But if they go to different states in any DFA, then you need infinite number of states, which is not possible. So ultimately, what I can say, I can say that this language is non-regular. There is no DFA for this language. Okay? Yes or no? So very easily you can prove it. Now let's move on. Now let's see this language. And let's prove that this language is non-regular. Okay, first you understand this language, then we will prove that this is a non-regular. So tell me, in this language, what you have? In this language L2, which strings you have? Just focus here. We have this type of strings. Read this. Here you can notice I. I is any positive integer. I is any positive integer. Means I can be 1, I can be 2, I can be 3, 4, and so on. Okay. So I is any positive integer. Now you notice here. Here you can notice this type of strings we have where we have 0 1, then 0 0 1, then 0 0 0 1, then 4 0 1, and so on. So you tell me, if I put I equal to 1, then what I will get? Okay, here I have I. Okay, so you can easily see 0 1, then 0 0 1, 0 0 0 1, and I 0 1. Yes or no? So now you tell me, if I put I equal to 1, because I is positive integer, so if I put I equal to 1, which string I will get? If I put I equal to 1, let me know. If I put I equal to 1, then I will get this string 0 1. Okay, if I put I equal to 2, what I will get? If I put I equal to 2, I will get 0 1 0 0 1. If I put I equal to 3, I will get 0 1 0 0 1 0 0 1. Okay, yes or no? If I put I equal to 4, what I will get? I will get 0 1 0 0 1 0 power 3 1 0 power 4 1, like this. I hope you are getting the point. Okay, so remember, this you will get when you put I equal to 1. This string you will get when you put I equal to 2. This string you will get when you put I equal to 3. This string you will get when you put I equal to 4, and so on. So this is an infinite language or finite? Tell me. Yes, this is an infinite language. Yes or no? I can put I equal to 1, 2, 3, 4, 500, 10,000 crore. Yes or no? So like this. So this is your language. Did you understand the language? First of all, tell me, which strings belong to the language, which strings do not belong to the language. Did you understand? Okay, so remember, our language, if you notice, this is like this. We have 0 1, then 0 0 1, then 0 0 0 1, and so on. 0 power I, 0 power I 1, where I is a positive integer. The question is saying that I is a positive integer. Okay, or I can say I is basically where I is greater than equal to 1. So this is the language. Now in this language, tell me which strings are not in the language. For example, tell me about this string 0 1, then 0 0 0 1. Is this string belong to the language or not? This string definitely not in the language. Yes or no? Okay, but you can notice 0 1 0 0 1, this belongs to L. Okay, yes or no? So very simple. I hope you understood. For example, if your string starts with 1, then this is not in the language. Okay, your empty string is not in the language. Okay, empty string, that is not in the language. So very simple. Like this you can understand what is the language. The language, you can see, can I have this string, for example 0 0 1, then 0 0 0 1? This, what about this string? Tell me, this string is in the language or not? 0 0 1 0 0 1, 0 0 1 0 0 1. No, this is not in the language. Okay, because remember, our string should start from like 0 1 0 0 1, like this. For example, you can easily see here 0 1 0 1 0 0 1 0 1 0 0 1 0 0 1 0 1 0 0 1 0 0 1 4 0 1. Okay, like this. Okay, I hope you are getting. Basically, this type of string we have. For example, 0 1, then 0 0 1, then 0 power 3 1, then 0 power 4 1, then 0 power 5 1, 0 power 6 1. Yes, this belongs to L. Okay, this string will belong to L because here basically I value is equal to 6. Okay, understood? So first you understand the language. Now, after understanding the language, now let's solve this question. What do you think? This is regular or not? What do you think about this language? We have seen what the language. Okay, that is like 0 1 0 1 0 1 0 1, then 0 0 0 1, 0 1 0 1, then 0 0 0 1 4 0 1, and so on. What do you think? This language is regular or not? This language is not regular. Yes or no? There is comparison here. Okay, where is the comparison? Can anyone tell me where is the comparison? See, the comparison is like this. If you look at any string, okay, in this W, if you look at any string, for example, let's assume the string has, okay, the string has a, I can say a big length. Okay, now you tell me, okay, at any point, if you are standing here, if you are standing here, then tell me, and let's assume here, so okay, here you have seen some ones. Okay, basically here you have seen some zeros and ones, some part you have seen here. Now you tell me what will come here. For example, tell me how many zeros will come here. Let me know. I am asking how many zeros will come here? For example, 0 power n 1. How many zeros will come here? That will depend on how many zeros came here. Yes or no? Do you agree? That will depend on how many zeros came here, like this. So can I say there is a comparison here? Can you notice there is a comparison here? Okay, basically this. Okay, how many zeros are coming here? This actually will depend on this. Okay, so you have to remember or not? Tell me. For example, now tell me what is the next thing that will come. Just tell me what the next thing will come. Let's assume you are standing here. Let's assume you are standing here. Then tell me what is the next thing that will come in this string w. In this string w, what is the next part? What will come? That will be 0 power n plus 1 1. Okay. Now, do you understand that you have to remember? Yes or no? We have to remember this thing. This thing we have to remember. Do you agree with me? Okay, so this is what I am saying, that so there is a comparison here. I hope you understood. There is comparison, and there is infinite possibilities of comparison. We have infinite possibilities of comparison. For example, after this what will come? Okay, after this what will come? That will come 0 power n plus 2 1. Okay, yes or no? So can you notice there are infinite possibilities of comparison? I hope this point you are getting. Okay, so very simple. This language is a non-regular. Is this clear? This language, if you notice, this language is a non-regular. Okay, because in this language there are infinite possibilities of comparison. Okay, where are the infinite possibilities? Let me tell you. In this language, where are the infinite possibilities of comparison? Let me show you possibilities of comparison. So the infinite possibilities of comparison are like this. For example, okay, if you have this string, then after this string what should come? After this should come. Yes or no? There is infinite possibility. For example, if your string is, let's assume this is your first part of the string, then after this what should come? Sorry, if this is your first part of the string, then after this what should come? After this 0 0 0 1 should come. Yes or no? Like this. If your first part of the string is like this, let's assume this is the first part of the string, then after this what should come? Then after this should come. Okay, I hope you are getting the point. And so on, and so on. So there are infinite possibilities of comparison. Do you agree? Okay, so that is the reason I can say this language is a non-regular. Okay, is this clear? So very easily I can say this language will be non-regular L2. This L2 is a non-regular. Simple point. Okay. Now, can you prove it using our formal method? Let me know. Using our formal method also you can prove, because remember, these infinite possibilities you can consider. Okay, these infinite possibilities. Consider these infinite possibilities as your set S. Okay, so remember the formal method. Let me write it. For this language, what you can do, you can basically create this infinite set S, and this infinite set S will be like this. These infinite possibilities you consider, because these are the infinite possibilities, and so on, they can keep going. Okay, so just consider these infinite possibilities. You can see 0 1, then 0 1 double 0 1, 0 1 double 0 1, then triple 0 1, and so on. Okay, so consider this set S. Is this clear? So this infinite set S you can consider this infinite set. Now you tell me a very simple point. If any two of them go to same state in any DFA, will the problem happen? Yes, the problem will happen. Okay, let me prove it. I will prove that if any two of them, because remember this is the infinite set, there are infinite number of strings here. So if any two of them, if they go to same state in any DFA, whatever DFA you assume, okay, if any two of them, whatever two you take, for example, you can take these two, you can take these two, so whatever two strings you take from this set, and if they go to same state in any DFA, then problem will happen. So what I can say? So I can say that these strings must go to different states. Yes or no? All these strings, all of them, they should go to different states in any DFA. But if they go to different states, okay, all these strings, if they are going to different states in any DFA, then we need infinite number of states. That is not possible. So that is the reason there is no DFA exist. Yes or no? Very simple point. I hope you understood. Now you can prove it, that if any two of them you take, whatever two strings you want, you can take. If they go to same state, then problem will happen. Tell me which string should I take? Here, give me two strings. I will prove it, that if you take any two string, whatever two strings you want, you can take. If they go to same state, then problem will happen. So for example, you can consider these two strings. For example, 0 1. A student is saying that, sir, consider this string. From this set S you have to take. You have to take from this set S. Okay, because remember, these are the infinite possibilities. And from these infinite possibilities, I have created a set S. This infinite set S we created. From this set S, you give me any two string you give me. Whatever two strings from this set S you give me, I will show you that if they go to same state in any DFA, then problem will happen. Okay, so for example, you can consider this string. You can also consider, for example, 01, 001, 0001, 401. Okay, consider these two strings. Is this clear? Okay, so take these two strings. Now you tell me. Now I will prove it that now the problem will happen. Tell me how the problem will happen. Let me know. The problem will happen if you take, for example, what will happen in this state Q1 if this string comes. Okay, see, from the initial state, I am assuming that this string and this string, they are going to same state. Now I will show you that problem will happen. Okay, how to show? Very simple. In this state Q1, from this state Q1, where we will go on this string. Okay, from this state, where we will go on this string 001. So let's assume we will go to state Q. Will it be final or non-final? Tell me. Will it be final or non-final? See, if you make it final, then problem. If you make it non-final, then problem. Notice, if you make it final, is there any problem? And if you make it non-final, is there any problem? Yes, there is problem. This state Q, if you make it final, then also problem. Okay, what is the problem if you make it final? Tell me, this state Q, if you make it final, what is the problem? The problem is this string will be accepted. Should this string be accepted? Tell me, this 01, 001, 0001, then 401, and then 001. This string should be accepted or not? Tell me, this string should not be accepted. But if you make it final, this state Q, if you make it final, then this string will be accepted. Okay, yes or no? So this is what I'm saying, that this string will be accepted, which is a problem. Okay, now you tell me, if you make this state Q non-final, is there any problem? Is there any problem? Yes, there is problem. If you make it non-final, then this string will be rejected. Should I reject it? This string will be rejected. Should I reject it? No, this should not be rejected. So are you getting my point, that whatever two string you take, okay, in this set S, this is an infinite set S. In this set S, whatever two string you take, any two string you can take, your choice. Okay, so whatever two string you take, if they go to same state in any DFA, then problem will happen. So what should happen? These strings, they should go to different states in any DFA. This should go to different state, this should go to different, this should go to different, and so on. But if they go to different states in any DFA, then you need infinite number of states, because this is an infinite set. Okay. But in the DFA, we have finite number of states. So I can say there is no DFA for this language L2. Yes or no? So this language L2 is a non-regular. Please tell me, did you understand? This language is non-regular. Did you understand the proof? So whatever you do, I can say that our DFA, whatever DFA we assume, that is wrong. Whatever DFA we assume is wrong. So what can I say about L2? L2 is non-regular. Did you understand? Please tell me. This is a very nice question. Understood? Let me know. Okay. So are you enjoying this formal method? This is actually very good method. Using the formal method, you can prove, you can formally prove that this language is regular, this language is non-regular. Okay, so with confidence you can prove that yes, this is a non-regular language. So I hope you understood. We have seen the formal method, we have seen the informal method, every method we have seen. Now let's move on. Now let's solve this GATE 2008 question. Which of the following are regular set? So some languages are given to us. Let's see which of them are regular set. You can see this option number 3, a power n, b power m. This we have already seen. This language is a non-regular. In the previous lecture we have already seen. Let's see the remaining ones. Okay, so let's see the first one, a power n, b power 2m. Is this regular? Tell me the language. Look at the language, that is a power n, b power 2m. Is there any comparison between n comma m? Here n is greater than equal to 0, m is greater than equal to 0. Is there any comparison between n comma m? There is no comparison. Yes or no? Here you can easily see that in this language there is no comparison between m comma n. We have no comparison between m comma n. Okay, so what I can say, if there is no comparison between m comma n, here you can easily write the regular expression. For this language, can you write the regular expression? It is simply basically any number of a, because remember, that n is greater than equal to 0. Okay, n is greater than equal to 0. So remember, any number of a followed by m is greater than equal to 0. Okay, so you can see, but there is b power to m. It means even number of b's. Okay, any number of a followed by even number of b's. This is the regular expression. Is this clear? Any number of a followed by even number of b's. This is our regular expression. Because we have regular expression, so what I can say? Because there is regular expression, so what I can say? So this language 1 is a regular. Okay, is this clear? So this language 1, I can say this language 1 is a regular. Understood? Please tell me. Okay, because I am calling this L1, this language L1. So this is regular. You can easily create the finite automata also. For example, NFA, DFA, you can create. What will be NFA? Okay, you can easily see NFA will be initial state will be final. Here you can easily see that empty string is accepted. Any number of A are coming, that will be accepted. Okay, after that, if B is coming, don't accept. Okay, if B is coming, don't accept. Okay, now if another b comes, then what you can do? Then you can accept. Okay, is this clear? Another b comes, accept. Then if another b comes, then just wait for one more b. So that's it. This is your NFA. Is this clear? You can easily see any number of a are coming, accepted. If b comes, don't accept, because we want even number of b's. So if another b comes, then we accept. Okay, so like this you can easily see. So here what will happen? Here a star is accepted, and if you have even number of b's, those are also accepted. So the final state will be, this will be final state, this will be final state. You can see this is our NFA. Okay, so because you can create NFA, so what I can say? Because NFA exists for L1, so what I can say? So L1 is regular. Okay, now let's move on. Let's see this one, L2. Tell me, this L2, is this regular or not? Here we have n equal to 2 power m. Okay, it is like this, a power 2n, b power n. This is what I can say. Okay, is this clear? N is greater than equal to 0. So here we have a comparison, yes or no? And there are infinite possibilities of comparison. Do you agree with me? Here you can easily see we have like this, that number of a must be double of number of b. Okay, yes or no? And you can see n is greater than equal to 0. So basically here we have unlimited comparison. There is unlimited comparison. Okay, I can say infinite possibilities of comparison are there. What are the infinite possibilities of comparison? Tell me. Tell me the infinite possibilities of comparison. These are the infinite possibilities of comparison. For example, if you have 2a, then how many b's should be there? There should be 1b. Yes or no? For example, if you have 4a, how many b's should be there? 2b should be there. For example, if you have 6a, then 3b should be there. If you have 8a, then 4b should be there. Are you getting my point? Please tell me. And so on. And so on. Okay. Yes or no? Number of a can be any even number. Is this clear? Please tell me. Number of a, that is any even number. Here you can easily see. Okay, so this is the idea. I hope you understood. So remember, these are the infinite possibilities, because remember, it's like if you have a power 2, then you must have b power 1. If you have a power 4, then you must have b power 2. If you have a power 6, you must have b power 3. If you have a power 4, you must have b power 4, and so on. If you have a power 100, then b power 50. If a power 1 crore, then b power 50 lakhs. Yes or no? Something like that. I hope you understood. So very simple. So there are infinite possibilities of comparison. And because there are infinite possibilities of comparison, you can see we have infinite possibilities of comparison. So that is the reason I can say this language L2 is a non-regular. Okay, and if you want to formally prove it, that also you can do. Basically, for this language L2, this is our language L2, that is a power 2 and b power n. Okay, so for this language, what you can do, you can consider these infinite possibilities as set S. Okay, is this clear? Basically, this set S you can take a power 2, a power 4, a power 6, a power 8. Okay, a power 8, a power 10, and so on. Is this an infinite set or not? Tell me. This is an infinite set. Okay, so you can easily see what I'm doing. See, these infinite possibilities I'm considering as a set S. Is this clear? These are the infinite possibilities because number of A can be anything. Number of A can be 2, 4, 6, 8, and so on. Number of A can be 0 also, no problem. Okay, so you can easily see that these are the infinite possibilities. I'm considering these infinite possibilities as my set S. Okay, now what I will do, tell me. Now I will prove that if any two of these strings, here you take whatever two strings you want to take. For example, you can take these two strings, you can take these two strings, whatever two strings you take here, if they go to same state in any DFA, if they go to same state, then problem will happen. Okay, this is what I will prove. So tell me then what should happen. Means in any DFA, these strings, any two of them, whatever two you take, they cannot go to same state. Okay, what it means? It means that they should go to different states in any DFA. Okay, all of them they should go to different states. But this is infinite set. If all of them are going to different states, then you need infinite number of states. Okay, in the DFA we have finite number of states, so definitely there is no DFA for this language. Okay, so now what I need to do, I need to prove that if any two of them, whatever two I choose here, any two I choose here, and if they go to same state, then problem will happen. Okay, so tell me which two I should choose. Give me randomly any two. I want to prove that if any two of them you take, and if they go to same state, then problem will happen. Okay, so randomly you give me any two string. For example, you can take these two string like a power 2, a power 5. Okay, a power 2, a power 5, or see, a power 5 is not here. Okay, so don't take a power 5. See, consider this set as, look at the set as, at least look at the set S. From this set S, you take, give me two strings. Okay, because remember, these are the infinite possibilities. I told you these are the infinite possibilities. A power 2, B power 1. If a power 4, then B power 2. If a power 6, then B power 3. If a power 100, then B power 50. So these are the infinite possibilities. I'm considering these infinite possibilities and I'm creating this set S. Now I want to prove that in this set S, if you take any two string, whatever two string you take, then if they go to same state, then problem will happen. Okay, so for example, I can take a power 2 and I can take maybe a power 70. Okay, so now you tell me how the problem will happen. Very simple. Tell me here, from this state q1, if b power 35 comes, then where should I go? If b power 35 comes, then where should I go? Tell me, should I go to final state or should I go to non final state? Should I go to final state or should I go to non final state? Tell me. I'm asking that. Let's assume these two strings are going to same state. Now in this state q1, if b power 35 comes, then should I go to final or should I go to non final? If I go to final, then problem. And if I go to non final, then problem. See, if I go to final, then what will happen? If I'm going to final, then this string is accepted. Should this be accepted? Tell me. This string is accepted, so this string is accepted, and that is a problem. So if I make this state q final, if I make it final, then problem. If I make it final, then there is a problem. Then there is a problem because this string will be accepted, which is a problem. Now you tell me, if I make it non-final, then is there any problem? Again, there is problem. Now this string will be rejected. A power 70, B power 35. This is rejected. Should I reject it? Tell me, should I reject this string? Let me know. This string is rejected. So this is another problem. So whatever you do, there is a problem. Are you getting my point? If you make it final, then problem. If you make it non-final, then problem. I cannot make it final. I cannot make it non-final. So what should I do? Yes or no? Are you getting my point? So I can say, that our language is has no DFA. Is this clear? A power 2 and B power n has no DFA. Okay, this language has no DFA. Okay, so it is a non-regular. Please tell me, did you understand? Very simple point. Is this clear? Now, a student is asking, sir, what about a power 0? We don't care about the corner cases. This is already infinite set. Okay, if you add one more string, will it matter? Tell me. This is already infinite set. Okay, we don't have to worry about some small cases. For example, if I remove these three also, then also it is infinite set. I can consider this also. Okay, are you getting my point? Yes, I know there will be a power 0, then b power 0. Okay, let me write it. For your satisfaction, let me write it. But I am saying that it does not matter. Because I am looking for infinite possibilities of comparison. I am looking for infinite possibilities of comparison. Now you tell me, will one or two things matter? Tell me. If I am looking for infinite possibilities of comparison, then few strings, 2, 3 strings, 4, 5 strings, will they matter to me? They will not matter to me. Yes or no? I just want infinite possibilities of comparison. Here you can see there are infinite possibilities of comparison. One or two strings don't matter to me. Okay. So don't worry about one or two strings, because here we are dealing with infinity. Okay. When you are dealing with infinity, then you don't have to worry about one, two things. Okay. Yes or no? So very simple point. Here you can notice that there are infinite possibilities of comparison. Now from these infinite possibility of comparison, I'm creating set S, and then you can notice that in this set S, if you take any two string, whatever two string you take, okay, you can choose any two string from this set S. From this set S, you take any two string. If they go to same state in any DFA, then problem will happen. So I can say there is no DFA for this language. So this language is non-regular. Okay, understood? Now let's see this one. A power n, b power m, where n is not equal to m. This language we have already seen in the previous lecture. Do you remember? In the previous lecture, we have already seen this language is a non-regular. Okay, the proof we have seen in the previous lecture. You can watch it. The link I will provide you in the description. You can watch it. Okay, is this clear? A power n, b power m, where n is not equal to. So you can see a power n, b power m, n is not equal to m. So again there is a comparison here. Again there is unlimited comparison, because n should not be equal to m. So again there is unlimited comparison, or I can say infinite possibility of comparison are there. Unlimited comparison is there. Infinite possibility of comparison are there. That is the reason this language is a non-regular. Okay, if you want to know the formal proof we have already seen in the previous lecture. You can watch it. I have already given to you. Okay, so this is a non-regular language. Now let's move on. Now let's see this language. Tell me about this language. Is this language regular or non-regular? Tell me. Here you can easily notice we have x, c, y. Okay, we have x, then there is c, then there is y. And what is x comma y? X is a string, remember, y is a string. Okay, the question is saying that x is a string, y is a string. Both are binary strings, a comma b whole star. Okay, x comma y, they don't have c. Remember, x comma y, they are binary string, they don't have c, they don't have this symbol c. Okay, so now you tell me, this is regular or not? First of all, you tell me here the symbol c, is this middle symbol? Tell me a simple point I'm asking. Is this middle? Is this middle symbol? Can I say this is the middle symbol in your string? Is this middle symbol in our string? Is this middle symbol in every string? Let me know. Is this middle symbol in every string? The answer is no. It may or may not be middle, because remember, please understand, what is x comma y? They belong to a comma b whole star. Okay, they have nothing to do with each other. Do you agree with me? Here, if you notice, x comma y have nothing to do with each other. X comma y have nothing to do with each other. Yes or no? Do you agree? Because both belong to a comma b whole star. So remember, in this language, if you notice, in this language you have this type of strings. X can be any string, y can be any string. Okay, x belongs to ab star, y belongs to ab star. For example, I can have c. This string belongs to my language. For example, I can have ac. Yes or no? In this AC, if you notice, here you can notice in this string AC, tell me what is X, what is Y in this string AC. X is A, and what is Y? Y is empty string. Are you getting my point? Yes or no? For example, what about this string? Will this string be in the language? What about this string? Tell me. Yes, this string will be in the language. In this string, you can easily notice that this part is basically X, this part is basically Y. Okay, yes or no? So like this, I hope you understood. Please tell me. So did you understand this language? So here remember, this c is not the middle symbol here. This c may or may not be middle symbol. Okay, so please understand here, because x comma y, if you notice, those belong to a comma b whole star. Okay, x comma y, they belong to a comma b whole star. You tell me, look at this string and tell me, is this belong to my in the language? For example, what about this string? This string belongs to the language or not? Tell me. Let me know. This string. This string does not belong to the language. Why? What is the reason? Because remember here, if you look at x, y, they don't contain C. Yes or no? They don't contain symbol C. So there is exactly one C. Okay, here I can say that there is exactly one C. We have exactly one C. Do you agree with me? Actually, this language is exactly one C. Okay, yes, this language is regular because this language is exactly one C. Okay, in this language, if you notice, we have this language L, or I can say this language L4. This is basically strings containing exactly one C. Strings containing exactly one C. Is this clear? Please tell me. Okay, this is our language and our alphabet, that is ABC. What is the alphabet? The alphabet, that is ABC. This is the alphabet. Okay, I hope you understood. So remember, this is our language here. Okay, so what will be the regular expression? The regular expression will be what? That is very simple. There is exactly one C. There is exactly one C. So here, what we can put? Here we can put any string of A comma B. Here we can put any string of A comma B, and here we can put any string of A comma B. This will be your regular expression. Is this clear? Okay, please tell me. So very simple. This is the regular expression. So this language is regular. Is this clear? So I can say this language L4 is a regular language. Okay, because please try to understand what is this fourth language. In the fourth language, you have this type of string where x, c, y. Where remember x comma y, they are just strings. This x comma y, they are any binary string. A comma b whole star. So they are any binary string. So if you think about it, we have exactly one C. Okay, so I can easily say that this is basically exactly one C. But remember, your alphabet is A comma B comma C, means your strings have A comma B comma C. This is the alphabet. Now you can easily see I can create the NFA. Tell me what will be the NFA? The NFA will be like this. That in the initial state, remember, in the initial state, any number of A comma B can come. Then exactly one C should come. Not more than one, not less than one. Now I will go to the final state. Now in this state, any number of A comma B can come. So this is the NFA. So here I can say that this language, this L4 is a regular language. Okay, understood? Please tell me. So this is the idea. Very simple. So finally, what is the answer here? Which are regular set? The question is asking which of them are regular. So you can see this is regular. Also this is regular. Okay, yes or no? These two are non-regular. And so finally answer will be 1 comma 4th. Answer will be option A. Okay. Now let's move on. Let's solve this gate 2014 question. L1 is given to you, that is A power n is greater than equal to 0. Basically A star. L2 is B power n is greater than equal to 0. Consider L1 dot L2. This is regular. L1 dot L2 is this. Tell me which statement is correct. Okay. So very simple point here. L1 is given to you, that is A star. Basically that is A power n, where n is greater than equal to 0. Okay, I can say that this is regular, right? Because this is your A star. So definitely this language is regular. Okay, and what is L2? L2 is B power n, where n is greater than equal to 0. Okay, so this is basically B star, any number of B. So this language is also regular. Now two options are given to you. The first option is, what can you say about L1 dot L2? Is this regular? The first question is asking, is this regular? I told you regular dot regular, that is regular. Yes or no? We have already seen that concatenation of regular languages is regular. If you have regular language concatenation with regular language, regular concatenation with regular, that is regular. Okay, correct. So easily you can see that this L1 is regular, this L2 is regular. Okay, this L1 is regular, this L2 is regular. So automatically what I can say? I can say this result also will be regular. Okay, is this clear? Very simple. Okay, actually you can see what will be the L1 dot L2. Tell me. Let me know what will be L1 dot L2. If I ask you what will be L1 dot L2, what that will be? Remember, L1 dot L2 means any string of L1 concatenate with any string of L1, L2. Yes or no? Okay, is this clear? So tell me, is this correct if I write like this? For example, L1 dot L2, is this correct if I write that, okay, A power 0, B power 0? a power 1 b power 1, a power 2 b power 2, a power 3 b power 3. Like this if I do, like this if I do, is this correct L1 dot L2? Can I say this is L1 dot L2? No, this is not L1 dot L2. This is wrong. Okay, this is wrong. Why this is wrong? Because remember, concatenation means what? Concatenation means any string of L1 concatenate with any string of L2. Please understand. Concatenation means, okay, from here you take any string, okay, any string of L1 concatenate with any string of L2. W can be any string of L1 and X can be any string of L2. Okay, is this clear? This is the idea. So remember, any string of L1, for example, you can take this, for example, you can take this string of L1 and you can take, for example, this string of L2. You can take this string of L1, you can take this string of L2. You can take this string of L1, you can take this string of L2. You can take this also. You can take this also. Okay, are you getting my point? You can take a power 10, b power 100. This is also fine. Are you getting my point? What I am saying? So very simple point. Remember what is L1 dot L2? That is basically, okay, let me write it here. So here you can easily see that your L1, your language L1, that was basically a power n, and language L2, that was b power n. Okay, so don't say that from here, don't say that L1 dot L2 will be a power n, b power n. Okay, is this clear? Can I say the answer will be a power n, b power n? No, this will not be the answer. This will not be the answer, because please understand that, see, this n and this n, do they have anything to do with each other? Tell me. A very simple question I am asking. In this L1 there is a power n is greater than equal to 0, means here you have any number of a, here you have any number of b. Then tell me, this n, what about this n and this n, do they have anything to do with each other? They have nothing to do with each other. Yes or no? There is no relation between them. There is no relation. Okay, is this clear? So you can easily see what will be L1 dot L2. L1 dot L2 will be any string of L1, for example, a power n, any string of L2, for example, b power m, okay, where both are greater than equal to 0. This is your L1 dot L2. Okay, is this clear? And you can easily see, I can write regular expression for this. Any number of a followed by any number of b, remember. Okay, any string of L1 concatenate with any string of L2. It's like this, any number of a followed by any number of b. Okay, any number of a followed by any number of b. So the regular expression will be a star b star, and this is regular. Yes or no? So remember, this language, if you notice, this language is regular. Okay, understood? So very simple point, I hope you understood. And you can easily see that because L1 is also regular, L2 is also regular, so their concatenation must be regular. Okay, you can easily see. So L1 dot L2, I can write it a star b star. Okay, and you can see this is a regular. Very simple question. So for this question, the answer will be what? Which option is correct? Here you can notice L1 dot L2 is regular. Yes, this is true. Okay, because what is L1? You already know L1 is a star and L2 is b star. So if you look at L1 dot L2, L1 dot L2, that is like any number of a followed by any number of b, a star b star. Okay, so can I say L1 dot L2 is equal to this? No, this is wrong. This is false. Okay, actually L1 dot L2 actually will be regular. This actually will be regular. And but if you look at this option 2, this is actually non-regular. Yes or no? Actually, L1 L2 will be regular because L1 is regular, L2 is regular, so their concatenation will be regular. But if you look at option 2, this is actually non-regular. Yes or no? Is this clear? So very simple. Here you can easily see this is non-regular. So definitely this is false. And which statement is correct? Answer will be option A. Okay, let's move on now. Tell me the answer for this question. Is this language regular or not? Let me know. In this language, can I say there is comparison here? Can I say there is comparison? Because here you can easily see that n is greater than equal to 0. So this is an infinite language, n can take any value. So can I say there is comparison that you must have, okay, n is then n is. So for example, if you have 100 A's, okay, then you must have 100 A's. So there is comparison. So there is comparison, and there is unlimited comparison, and there is unlimited comparison. So can I say this language is non-regular? Tell me, what should I say? Can I say this language is non-regular? Is this correct? This argument that I told you, this argument, is this correct argument? No, this argument is wrong. What was the first step to check whether a language is regular or not? Tell me. This complete thing is wrong. This is a this complete thing. Okay, is this clear? This is wrong. Tell me why this is wrong. What is the reason that this is wrong? This whole thing. Okay. So, because first you understand the language. See, many students, what they do, many students, when they see the comparison in a language, then they just directly say non-regular. Okay, because when they say comparison, okay, a power n, there is comparison, so it is non-regular. Yes or no? This is what they do. When they see comparison, they will immediately say that it is non-regular. Okay, but you should understand the language. Yes or no? Just wait. Just wait. What is the hurry? So you understand the language. I told you this was the step one in detection of the language class. If you remember, the step one, that is understand the language carefully, which strings belong to the language, which strings do not belong to the language. First you understand the language. So here if you notice, what are the strings in this language? This is a power n, a power n. What I can write it? I can write it a power 2n. Yes or no? Isn't it? This is basically a power 2n, n is greater than equal to 0. It is just even number of a's. Yes or no? This is the regular expression, even number of a's. And because we have regular expressions, so L is regular. Please tell me, did you understand? So just understand the language first. Then you solve the question. Tell me the answer for this question. A power n, B power n. We have A power n, B power n. So tell me, this language, is this regular or not? Let me know. This is regular because this is a finite language. Here n is less than equal to 1000. So this is actually finite language. Yes or no? In this language, we have finite number of strings. Okay, yes or no? In this language, we have a power 0, b power 0, a power 1, b power 1, and then so on, a power 999, b power 999. That's it. This is what we have. This is a finite language. Is this clear? And because this is a finite language, every finite language is regular. Yes or no? Every finite language is regular, I told you. Okay, so this is the regular language. And what will be the regular expression for this language? Tell me. Tell me what is going to be the regular expression. I told you regular expression will be okay epsilon or AB or ace or double AB, double A double B, and so on. A power 999, B power 999. This is the regular expression. Is this clear? It is a long regular expression, but it is correct. I know this is a very big regular expression. Okay, this is a very big regular expression, but this is correct regular expression. Yes or no? Because this is a finite language. Every finite language is regular. Okay, let's move on now. Let's solve this GATE 2015 question. Which of the following are regular language? L1, L2, L3, three languages are given to you. So first, let's see what about L3. Tell me. First, you tell me about L3. A power P, B power Q, C power R, where P, Q, R are greater than equal to 0. There is no relationship between P, Q, R. Yes or no? There is no relation between P, Q, R. So this language, can I say this is your A star, B star, C star? Because P, Q, R, they are greater than equal to 0. Okay, so I can say any number of A followed by any number of B followed by any number of C. This is the regular expression, so this is regular. Okay, yes or no? Very simple. Because in this L3, there is no relationship between PQR. A power P, B power Q, C power R, where PQR greater than equal to 0. So you can see any number of A followed by any number of B followed by any number of C. So this language is definitely regular. Okay, L3. Okay, so what about the remaining? Let's see the remaining. This L2 we have already seen. Do you remember in the previous lecture we have already seen this L2? What is this L2? This is A power n, B power m, where both are not equal. Okay, where both are basically different. This we have already seen in the previous lecture. Here you can see there is a comparison, unlimited comparison. Okay, infinite possibilities of comparison are there. Okay, and the formal proof we have seen in the previous lecture that this language is a non-regular. Okay, the formal proof, if you want to know what are the formal proof of this language, then you can watch the previous lecture. Okay, now so only one language is remaining, that is L1. We have already seen L2 is a non-regular. Yes or no? L2 non-regular and L3 that is regular. And now we have to check what about L1. So let's check about L1. What is this language? Here you can easily notice in this L1, look at this L1. Here we have this type of string where you have W, okay, then there is X, then there is X, and then there is WR, and then there is W reverse. Okay, is this clear? There is W, then X, then W reverse, where you can easily notice that X comma W they are strings. X comma W they are strings, and remember they are non-empty string. X comma W they are non-empty string because length of W greater than 0, length of X greater than 0, so they are non-empty string. And what is WR? This is the reverse of string W. Okay, so in this language we have this type of string W X W reverse, where X comma W they are non-empty string. Length of W is greater than 0, length of X is greater than 0. So tell me, this language, does it have infinite matching? Does it have infinite possibility of matching? Because here, for example, if you put, okay, if you put W here, then you have to put W reverse here. Yes or no? And X can be anything. So now you tell me, in this language, can I say there is infinite matching here? Let me know. Can I say there is infinite matching? Infinite possibility of matching? Let me know. Look at this and tell me, can I say there are infinite possibility of matching? Comparison? Infinite possibility of comparison or matching? So can I say this language will be non-regular? Let me know. Please tell me. This argument, is this argument correct? That there are infinite possibilities? Okay, so can I say this language is a non-regular? Let me tell you, this is wrong. Okay, this analysis is wrong because you are not understanding the language. Again, I told you the first step in detection of language class, that is, you first understand the language, which strings belong to the language, which strings do not belong to the language. First you understand it clearly. Yes or no? Which strings are in the language, which strings are not in the language. First you understand that. So remember, this whole thing is wrong. Okay, is this clear? So let me write it. This whole thing is wrong. Okay, so now again I'm telling you, see what students do when the students will see okay, WWR is there. See, many students what they will do, they will do they will do like this, that okay, there is W, okay, there is WR, so there is matching, so this is non-regular. Yes or no? This is what they will do. Majority of the students, when they will see this matching WWR in the string, when they will see this WWR, when they will see, then they will directly say non-regular. Okay, but you should wait. Okay, you should understand the language. Yes or no? So what you should do, remember in the gate exam, okay, this is a nice meme, you can easily see, when you by heart concepts and you don't understand the concepts, without understanding, if you just by heart concepts, then in the gate exam what will happen? I'm about to end this man's whole year, or I can say career, right? Yes or no? So you can easily see, I told you that the step 1 in the detection of language class, that is, understand the language carefully, which strings are in the language, which strings are not in the language, clearly understand. Okay, is this clear? Now let's see here. Tell me, in this language, you tell me, okay, I am asking you, you tell me, look at this string and tell me this string will be in the language or not. I am giving you a string. I am giving you a string. Okay, this string you consider, for example, A double B, okay, then A B, okay, and then B. Now you tell me, this string, you look at this string BAA. Okay, now tell me, what about this string? Is this string in the language or not? Just tell me a simple point I'm asking. This string, does it belong to the language? In this language L1, do we have this string? Let me know. This string, do we have in this language or not? Yes, this string is in the language. See, see, just consider this as W. Who told you to consider this as W? Because I'm writing this in the green color, so is it W? I'm writing this in the green color, so why are you taking it as W? You take this as WR, and the remaining thing is your X. This is your X. So this string belongs to the language or not? Yes, of course. Is this clear? Please understand the language L1. In the language L1, what we have? In the language L1, we have that there is some string W which is non-empty. Remember, because X comma W, they are both basically non-empty. X is also non-empty, W is also non-empty because their length is greater than 0. Okay, so in this language, we have basically there is W, then there is X, then there is W, then there is W reverse. Yes or no? But you can see in this string what I can do. Remember, for example, this is W, this A I can take W. Okay, the remaining thing I can take as X. So this belongs to L. Is this clear? Please tell me. Okay, so I am writing in the green color and I am writing this in the white color. So you are thinking, your mind is thinking that okay, yeah, this is W, this is X. Why? Who told you that? Who told you that this is W? Okay, this can be W. This first symbol and last symbol you can take as W comma WR. Yes or no? Are you getting my point? So this language, this string actually belongs to the language. Okay, understood. So very simple point, remember here, because in this language, see what you can do. In this language, you notice, you just tell me a simple point. If your string, if you have a string, a simple point I'm asking, and you tell me the answer. Okay, let's assume there is a string which starts with A, which ends with A, and there can be anything here. Okay, can I say this will belong to the language which starts with A, ends with A, and if there is something here, can I say this will belong to the language? Tell me. Let me know. Can I say this will belong to the language? Yes, this will belong to the language. Yes, 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 because this you can take as W. So this will be W reverse. Okay, and the remaining part you can take as X. So this will belong to the language. Okay, now you tell me this type of string which is starting with B, ending with B, and in between you have something, something, something. Will it belong to the language? Will it belong to the language? Yes, of course, you can take this as B. You can take this as W. You can take this as W reverse. Okay, in between you can take as X. Yes or no? Are you getting my point? Okay, so very good. So far we have seen that if your string starts with A, ends with A, then it will belong to the language. If your string starts with B, ends with B, it will belong to the language. Now, what are the remaining strings? Which strings we did not consider? What about the remaining strings? For example, what about these strings? If a string is starting with A and tell me if it is ending with B, is it possible that it can belong to the language? Is it possible? If your string starts with A, ends with B, is it possible? Give me a possibility. Is it possible it can belong to the language? It can never belong to the language because remember, W comma X, they are non-empty. Yes or no? W comma X, their length is greater than 0. So they are non-empty string. So they must have at least one symbol. Yes or no? Yes or no? They are non-empty strings. They must have at least one symbol. So now you tell me, if your string is starting with A, ending with B, okay, in between you can have anything. You tell me what W you will take. Let me know. Can you take this as W? For example, can you take this as W? If you take this as W, then what should be the last symbol? If you take this as W, what should be the last symbol in the W reverse? The last symbol should be A. Are you getting my point? Tell me. A very simple point I'm asking. You can easily see. I'm saying that. See, you have W, then X, then W reverse. Okay. Now you notice if this is your W, which is starting with A, then there is X, then there is W reverse. Then the last symbol should be what? The last symbol should be A or not? Tell me. Are you getting my point? See, whatever W you take, if this is your W, okay, then there is X, and then there is W reverse. So you can note this A should be there here. If the first symbol is A, the last symbol must be A. Okay, yes or no? So remember, this string can never belong to the language. Okay, yes or no? Because if you consider this as W, then this is never W reverse. Then this is not W reverse. Correct? Whatever you do, this is not W reverse. Is this point clear? Let me know. So this is the idea, because if you start with A, then you should end with A. So this string is not in the language. Similarly, remember, if your string is starting with B and ending with A, it cannot belong to the language. So that's it. This is the complete analysis of this language. Did you understand? Tell me. Please tell me, did you understand this? So finally, I can say, in this language, which strings we have? Remember, in this language, we have done the complete analysis of this language. We have seen which strings belong to this language and which strings do not belong to the language. See here, if the first symbol is A and the last symbol is A, this string will belong to the language. Yes or no? These strings are in the language. If the first symbol is B, the last symbol is B, these are in the language. If the first symbol is A and the last symbol is B, these are not in the language. If the first symbol is B, last symbol is A, these are not in the language. Whatever you do, these are not in the language. So from here, what is the language? Let me know. From here. And remember, W comma X, they are non-empty. Already you can see that W is non-empty, X is non-empty. W comma X both have at least one symbol. Both have at least one symbol. So tell me, what is the smallest string you can create here? What is the smallest string you can create? Tell me. So your language will be what? In the language, smallest string in the language, you tell me. Tell me smallest strings in the language. In this language, L1. Okay, our language is L1. So you tell me, in our language L1, what are the smallest strings? The smallest strings will be either ABA or triple A or BBB or BAB. These are the smallest strings. Yes or no? Is this clear? Okay. You can see starting with A or ending with A. Starting with B, ending with B. So that's it. These are the strings. You can see these are the smallest length strings in our language. So now can you write the language? Tell me what will be this language? Can you write? This language will be like this. Start with A, end with A. In between, you can put A or B whole plus, because remember X is non-empty. Yes or no? The length of X is greater than 0. So X is non-empty. So X is non-empty. Is this clear? So remember, you can start with A, you can end with A. In between, you can put A or B whole plus. Anything you can put. Okay, yes or no? You can put anything. Or, or, or what can happen? You can start with B, you can end with B. In between, you can put A or B whole plus. So this is the regular expression. Agree? Yes or no? Please tell me. That's it. We found the regular expression. This whole expression, if you look at this whole expression, this is regular expression. So that is the reason what I can say. What about the language? The language is regular. Okay, is this clear? The language is regular. Please tell me, is there any doubt in this language? Let me know. This is the complete analysis of this language. Please tell me, is there any doubt here? Do you have any doubt here? So first you understand the language. Whatever question, remember in the GATE exam, if any question is coming, then first you understand which strings belong to the language, which strings do not belong to the language. You understand it clearly. After understanding the language clearly, which strings are in the language, which strings are not in the language, then you find out whether this is regular or not. Okay. So I hope this point is clear. So finally, I can say this language L1, this is actually regular. Okay. So tell me what will be the answer? Ultimately, what is going to be the answer here? So we have already seen this is a regular. We found that this is regular. So the answer will be, you can see, the question is asking which are regular languages. So answer is L1, L3. Okay, answer will be option A. Now let's move on. Let's solve this GATE 2008 question. The question is asking which languages are non-regular. Here the question is asking for non-regular L1, L2, L3. So tell me here, we have already seen this L2. This is non-regular in the previous lecture. Yes or no? L2 is palindrome. W reads same and same forward and backward. Okay, look at L2. This is basically your palindromes. Yes or no? All palindrome. This is set of all palindromes. Okay, actually one thing here, in this L2, what the alphabet is that given to you? In L2, the alphabet is given to you or not? Let me know. Alphabet is not given, but you can easily see from the option A, from the L1, from the L3, you can find out what the alphabet. Yes or no? Okay, from this option, from L1, L3, you can easily see what is the alphabet, because in this question L1 is given to you, L3 is given to you, so you can assume that your alphabet is basically 0 comma 1. Yes or no? Okay, alphabet is not given, but you can assume that this is 0 comma 1. This alphabet you can assume. Okay, from L1, from L3, so the same you can assume for L2. Okay, so you can see what is L2. L2 is basically set of all palindromes, because you can see W reads same and backward, same forward and backward. So this is basically set of all palindrome. In the previous lecture we have seen this is non-regular. If you want the formal proof, then where you will find in the previous lecture. Okay, is this clear? If you are interested in the formal proof, how to prove that this is non-regular, the formal proof we have discussed in the previous lecture. Okay, now what about the remaining ones? For example, this L3, or maybe you can look at L1. What about L1? L1 is finite language, yes or no? See, look at L1. L1 is 0 power m, 1 power n. Okay, where m is less than equal to n, is less than equal to 10,000. Okay, and this is greater than equal to 0. This is actually finite language, yes or no? This language, if you look at, this is actually finite. How many strings are there? We have finite number of strings, because remember m is less than equal to n first of all, and n is less than 10,000. So for example, this value can be maximum 10,000. Okay, yes or no? And this is a less than equal to n. So you can easily see that we have, this is a finite language. Every finite language is regular. Okay, yes or no? Every finite language is a regular. So this language is also regular. Very simple. Okay, so remember, in this language, if I change, for example, 0 power m, 1 power n, if I make it 0 power n, 1 power n, then also it will be regular. Because again what will happen? Again this is finite. Yes or no? Is this clear? Please tell me. So this language, if you look at a 1 power 0 power n, 1 power n, this is also regular. Why? Because this is finite. This language is finite, so it is regular. Okay, understood? Please tell me. So I hope this point is clear. Okay, now let's see the next one. We have already seen L2 in the previous lecture. This is non-regular. And what about L3? L3 is W contains even number of 0, even number of ones. This is regular. Yes or no? In our lectures, we have created DFA for it. Because in this language, look at L3. L3 has alphabet 0, 1, strings which belong to 0, 1 whole star. 0, 1 whole star. And the question L3 is saying that W contains even number of zeros, we must have even number of zeros, and we must have even number of ones. Okay, is this clear? We must have even number of zero and even number of ones. You can easily see that this is regular. You can create a DFA for this. We have already created DFA for this, so this is actually regular. Okay, and what will be the DFA? You can easily see in the DFA there will be 4 states. We only have to keep track of 4 states, because number of 0 either will be odd or even, number of 1 will be odd or even. So you can see there are only 4 states we need to take care. One state is where number of 0 is even and number of ones is odd. Okay, and you can see another is number of 0 is even, number of ones is odd. Another is where number of 0 is, okay, see here you can assume that number of 0 is even, number of ones is even. Okay, both you can understand that both are even. Okay, so like this basically you can do like this. Another is number of 0 odd and number of ones is even. And finally I can say number of 0 is odd and number of ones is odd. Yes or no? Because remember, the question is saying we want even number of 0, even number of ones. Okay, so if you look at, we are only interested in the parity, means how many zeros we have, basically even or odd, how many ones we have, even or odd. So we are only interested in the parity, even or odd. So these are the four possibilities. Yes or no? Either the number of 0 comma 1 both can be even, or number of 0 comma 1 they can be even comma odd, or they can be odd comma even, or they can be odd comma odd. Yes or no? Now tell me, in this, so there will be four states, we only care about four states, and we want even number of 0, even number of ones. Okay, we want even number of 0, even number of ones, so this will be final state, because I want even number of 0, even number of ones, so this state will be my final state. Okay, now what will be the initial state, tell me. The initial state, initially you can see, initially how many 0 we have seen, we have seen 0 0 0 1, so that is even. Initially we have seen even number of 0, even number of 1, so you can see this will be the initial state. Now you can easily make transition. Okay, in this initial state you can see, if 1 comes we will go here. In this state if 1 comes we will go here. In the initial state if 0 comes we will go here. In this state if 0 comes we will go here. In this state if 1 comes we will go here. Okay, in this state if 1 comes we will go here. In this state if 0 comes we will go here. Okay, yes or no? So like this will be your DFA, that's it. We have created minimal DFA. This is the minimal DFA for L3. So because we have created minimal DFA for L3, so what I can say, I can say this L3 is a regular. Okay, is this clear? L3 is regular. So finally in this question, L1 is regular because L1 is finite. This is a finite language, so this is regular. L3 is regular. L2 is non-regular. So finally answer will be L1 comma L3. The question is asking non-regular. The question is asking non-regular. Okay, non-regular. So L2. Answer will be option D. Okay, only L2. Now, one variation I want to discuss. See, look at this L2. In this L2, okay, this L2, you focus on this L2, that is saying W reads same forward and backward. Basically, W is palindrome. Okay, we know that palindrome, that is non-regular. Okay, yes or no? Palindrome, set of all palindromes, that is non-regular. But you tell me, if the alphabet is unary, then what will happen? Simple question I'm asking. If alphabet is unary, means let's assume your alphabet is, for example, A. Now, is this regular or not? Please tell me. This language, we know that this language is non-regular if alphabet is binary. Yes or no? Okay, for this language, we have already seen that this is a non-regular. This language is non-regular when alphabet is binary. Okay, now I'm asking, if the alphabet is unary, then what can you say? Then what can you say? For example, if your alphabet is A, then which are the palindrome strings? This is the set of all palindromes. So can you give me the palindrome strings? What will be palindrome strings? This will be palindrome, this will be palindrome, empty string also will be palindrome, double A will be palindrome, triple A will be palindrome. So can I say that you got A star, which is regular? Okay, is this point clear? Please tell me. So understand, in the gate exam, first you understand the language. Did you understand this? Please tell me. Let me know. Because remember, if your alphabet is unary, then if your alphabet is A, then every string is palindrome. Every string is palindrome. Yes or no? So the language is A star. That is regular. Okay, so take care. In the gate exam, whatever question is given to you, you should take care. In this question, we have already seen in the previous lecture that this set of all palindromes, this is non-regular when alphabet is A comma B. When your alphabet has at least two symbols, if your alphabet has at least two symbols, then this palindrome language is non-regular. Okay, but if your alphabet is unary, then you should take care. Here, if your alphabet is unary, then the language is becoming A star, which is regular. Okay, now let's move on. Now let's see this very important topic, that is, when can we say that a sequence of numbers is non-regular? When can we say that a sequence of numbers is regular, and when can we say that a sequence of number is non-regular? Let me explain what I want to say. Sequence of numbers, what it means. For example, prime number sequence. For example, prime number sequence. Is this regular or is this non-regular? Prime number sequence. Okay. For example, even number sequence. If I ask you the sequence of even numbers, for example, if I ask you the sequence of odd numbers, for example, if I ask you the sequence of this type of number, 2 power n, this type of numbers, okay. If I ask you the sequence of this type of number, n factorial number sequence, okay, is this clear? So this is what I'm asking, that in the gate exam, if they ask you that which of them are regular, which of them are not regular, this is the point. Okay, understood this? I'm asking sequence of number. When can I say sequence of numbers are regular, and when the sequence of numbers will be non-regular? For example, if you have prime number sequence, means basically set of prime numbers, or set of even numbers, or set of odd numbers, or set of 2 power n numbers, or set of n factorial numbers, and so on. Okay, there can be more sequences. So which of them will be regular, which of them will be non-regular? This is what we need to check, yes or no. Which is regular, which is non-regular? We need to check which will be regular and which will be non-regular. For this, what we will do, we will see two methods. Okay, let me tell you, we will see formal method also, we will see the formal proof also, and we will see the informal method also. Both we will see, and both are important. Okay, we will see formal and informal both methods. Let's see both of them. So let's start. This is the first tip, or I can say this is the first guideline. Okay, I'm asking for sequence of numbers. Some sequence of numbers will be given to you. For example, prime numbers. Okay, maybe even numbers, odd numbers, maybe factorial numbers. Okay, yes or no, maybe 2 power n numbers. So you can see that some sequence of numbers will be given to you. Now let me tell you that when they will be non-regular. Okay, you can easily see if they have no repeating pattern, if they have no repeating pattern, okay, there is no repeating pattern, there is no predictable pattern, then they will be non-regular. Okay, is this clear? See, in the finite automata, if you notice, whether you take DFA or whether you take NFA, they work on the repeating pattern or not. See, in the finite automata, what you have, you have some states and there are maybe some loops, yes or no. Loop is a repeating pattern or not, tell me. For example, let's assume this is the loop A B A A. So this is a loop, yes or no? A B A. So this repeating pattern you got A B A, again this will repeat A B A, again this will repeat A B A. Are you getting my point? So remember, finite automata has basically, finite automata, this works on repeating pattern. There will be some repeating patterns. If there is self loop, that is repeating pattern, yes or no. Are you getting my point? So this is what I'm saying, that if your sequence does not have a repeating pattern, if there is no repeating or predictable pattern, then the language is non-regular. Okay, can you give me example? Can you give me a sequence which has no predictable or repeating pattern? Let me know. That is your prime number sequence. For example, prime number sequence, does it have predictable pattern? Tell me. Does it have a repeating pattern? Let me know. It does not have a repeating pattern, yes or no. In the prime numbers, we don't have any repeating pattern which is repeating, yes or no. So you can easily see prime number sequence that doesn't have a repeating pattern. Very simple. So remember, if the sequence has no repeating pattern, no predictable repeating pattern, then you can see the language is non-regular. Another point, if there is complex calculation, means, for example, in the sequence, if you want to find the next element, then if you need to do some complex calculation, if you need to apply some complex rules, then it is non-regular. Okay, another example, can you give me example for this? Can you give me example for this, where you have to apply some complex calculation to find the numbers in the sequence? In the sequence, to find the next numbers, you have to apply some complex calculation. That is again prime numbers, yes or no. The prime number sequence, in the prime number sequence, okay, what will be the next prime number? You need some complex calculation. Do you agree with me? Yes or no? Okay, for example, after certain time, okay, I know that small prime numbers you already know, yes or no. For example, single digit or double digit prime number you already know. But after some time, if you have triple digit prime number or 4 digit prime number, then can you, without calculation, without complex calculation, can you find out it is prime or not? Tell me. No, it is not possible, yes or no. So remember, very simple point, if you need some complex calculation or complex rule, to find the elements of the sequence, then it is a non-regular. For example, prime number sequence. Okay, let's see another one. That is, if you have non-uniform distance between elements. Understand this. If we have non-uniform, random, or I can say arbitrary distance between elements, non-uniform, arbitrary distance between consecutive elements, then that is a non-regular. Okay, let me give you example of this also. Prime numbers will help, yes or no? In this case also the prime number will suit, because in the prime numbers, do we have non-uniform distance between consecutive number or not? Tell me. Between consecutive prime number, is there a uniform distance? Do we have a uniform distance? Tell me. Between consecutive prime number, do we have a uniform distance? No, we don't have uniform distance, yes or no? So there is non-uniform arbitrary distance between elements. Let me give you one example. Consider this sequence, 2 power n sequence. In this 2 power n sequence, tell me, do we have uniform distance between consecutive elements? Consider this sequence. Basically, 2 power 0, that is 1, 2 power 1, that is 2, 2 power 2 power 2, 2 power 3, 2 power 4, 2 power 5, 2 power 6, 2 power 7, and so on. Now tell me, here do we have uniform distance or not? 2 power 0, that means 1. Here you have 2. Here you have 4. Here you have 8. Here you have 16. Here 32. Here 32. Here you have 64, then 128, then 256, and so on. Okay, so tell me, here you tell me, do you have some uniform distance or non-uniform distance? For example, here the distance is 16. Here the distance is 32. Here the distance is 64. Yes or no? Here the distance is 8. Are you getting my point? Is this clear? So you can easily see that in this sequence, in this 2 power n sequence, we have non-uniform distance between consecutive elements. Non-uniform and arbitrary distance if you have either non-uniform or arbitrary. Okay, or arbitrary distance if you have. Okay, then in that case, I can say your language will be non-regular. Okay, is this clear? Please tell me. So these are the 3 points we have seen. What are the 3 points? Tell me. The first point, if there is no repeating pattern, then non-regular. The second point, if you need complex calculation to find the elements in the sequence, then non-regular. And also, if you have non-uniform or arbitrary distance between consecutive elements, distance between consecutive elements, then it is non-regular. Is this point clear? Please tell me. Any of them is fine. Any of them is fine. Please tell me. Okay, is this clear? Let me know. For example, if you have non-uniform distance between consecutive elements, that is enough. That is enough. Your language will be non-regular. If there is no repeating pattern, then your language will be non-regular. Is this point clear? Please tell me. Understood? Okay. So very simple point. Now let's see a lot of examples. Consider this a power p, which is the where p is the prime number. A power p, where p is the prime number. So here you can easily see, first of all, in the prime numbers, we have no repeating pattern. The prime numbers don't have any repeating pattern. They need complex calculation to find the next prime number. And also, we have non-uniform and arbitrary distance between consecutive prime numbers. So this language, you can easily see this where p is the prime number, a power p. Okay, for example, a power 2, a power 3, a power 5, a power 7, a power 11, a power 13, and so on. Okay, where p is the prime number. So this is a non-regular language. Is this clear? Please tell me. Let's see the next one. For example, n factorial, where n is positive number. Okay, remember n factorial. This has non-uniform and there is no repeating pattern here. Yes or no? In the n factorial, we have no repeating pattern. There is no repeating pattern in the n factorial. Also, there is arbitrary and non-uniform distances between consecutive elements. Okay, for example, 1 factorial. Okay, 1 factorial. Then there is 2 factorial. Then there is 3 factorial, which is 6. Then 4 factorial, 24. 5 factorial, 120. 6 factorial, 720, and so on. Yes or no? Can you notice? It's like 1, 2, 6. Then 24. Then 120. Then 720. Yes or no? Is this clear? So you can easily see there is non-uniform distance between consecutive elements, arbitrary distance between consecutive elements. There is arbitrary distance. Yes or no? This is non-uniform, arbitrary, and there is no repeating pattern also. So you can easily see Okay, one of them is fine, no problem. So you can easily see this n factorial. This also will be non-regular. Non-regular. Is this clear? Okay, for example, in the gate exam, they can give you like a power n factorial. A power n factorial. Like a power 1, a power 2, a power 6, a power 24, a power 20, a power 720, and so on. Okay, is this clear? So you can see a power n factorial here. We have non-uniform distances, arbitrary distances between consecutive factorial numbers. So this is a non-regular. Okay, what about this? 2 power n, where n is positive number. Okay, see, in the gate exam, what they can do? They can give you like this, a power 2 power n. Okay, a power 2 power n. Like this, they can give you. So now you tell me here. Here also you can easily see it will be like this. See, a power, if I put n equal to 1, okay, then it will be like a power 2. Then if I put n equal to 2, it will be like a power 4. If I put n equal to 3, it will be like a power 8, then a power 16, then a power 32, then a power 64, a power 128. Yes or no? So you can see. So here also you can easily see there is non-uniform distance between consecutive elements. So this language is also non-regular. Okay. Is this clear? Please tell me. Let me know. So I hope you understood. Now you might be thinking, sir, this is fine. Okay, that we have seen which language is regular, which sequence is regular, which sequence is non-regular. That is fine. But is there anyone here who wants formal proof? Okay, after seeing so many formal proof, do you want formal proof for all of them? I can give you the formal proof that these languages are non-regular. These languages are not regular. I can give you the formal proof. Is there anyone here who want formal proof for these languages? Let me know. Let me give you. Okay, so let me give the formal proof for these languages. Like you can easily see 0 power p, where p is the prime number. Let's prove that this is non-regular. You can easily prove it. Okay, first of all, you understand the language here. What the language? Here, what are the language? So the language here, that is basically p is a prime number. So it is like 0 power. Okay, for a moment you can just take it a. Okay, it is like a power where p is a prime number. So p is basically like 2. Okay, like 3. These are the prime numbers, right? 2, 3, 5. Then there is 7. Then there is 11. Then there is 13. Then there is next 17, 19. Yes or no? So this is the language. Is this point clear? Now we have already seen that this language is non-regular. That is fine, because here you can easily see that we have no repeating pattern. There is arbitrary distance between consecutive prime numbers. Okay, and we need complex calculation to find the next prime number. Yes or no? So basically this is non-regular. But let's see the formal proof. What are the formal proof? Okay, let's see that. Formally, can we prove it that this is a non-regular? Yes, I can easily formally prove it. See, let me tell you, if these strings, whatever two string you take here in this, because this is infinite set, yes or no? This is infinite set. Do you agree? This is an infinite set. So let me tell you one thing, that in this set, whatever two string you take, whatever two prime number you take, for example, you can take these two, for example, you can take these two, for example, you can take these two, okay, whatever two, for example, you can take these two, okay, any two prime number you take, let me tell you, if they go to same state in any DFA, then problem will happen. Okay, this is what I can prove. See, this is an infinite set. In this infinite set, if I take any two prime number, take any two prime number you want, okay, and if they go to same state in any DFA, then problem will happen. So this language is a non-regular. Okay, is this clear? So this is what I am saying. So you can easily see. Let's see. Let's see the proof. What I told you. I told you that if any two of them go to same state, then problem will happen. So this is what I'm saying, that for this language, your language L1, this is basically a power p, where p is prime number. I am saying that for this language, this set S you can take. You can take the set as it is. Okay, like for example, this a power 2, a power prime basically, a power 3, a power 5, a power 7, a power 11, 13, and so on. Okay, so basically this set as you can take. Now let me prove it. I will prove it that you already know this is infinite. Okay, because prime numbers are infinite, so this is an infinite set. I will prove that if whatever two you select here, if they go to same state in any DFA, then problem will happen. Okay, here remember, here whatever two string you take, that is your choice. Whatever two strings I take here, okay, whatever two strings, if if they go to same state in any DFA, then problem. If they go to same state in any DFA, then problem will happen. So what it means? Remember, it means that these strings cannot go to same state. Yes or no? So all of them must go to different state, because whatever two you select, if they go to same state, then problem will happen. So I can say all of them should go to different states. But if all of them are going to different states, then you need infinite number of states. But your DFA has finite number of states. So I can say that there is no DFA for this language, and this language is non-regular. Yes or no? Very simple. So let me prove it here, that if I take any two strings, so tell me which two strings should I take? Give me any two strings, any two prime numbers you give me, and if they go to same state, any two prime number, you can give me any two prime number. If they go to same state from the initial state, if they go to same state, then problem will happen. Give me any two, whatever two you want, you can give me. For example, you can give me like, okay, you can give me for example a power 2, a power 3. Okay, tell me, will there be problem? Yes, there will be problem. You just tell me what will happen if a power 2 comes. Means from this state q1, where I will go on a power 2? Should I go to final or should I go to non final? If I go to final, then problem. If I go to non final, then problem. Yes or no? Is this clear? See, if I go to final, then what will happen? If I make it final, then what will happen? Then a power 4 accepted. Should I accept it? See, if I make it final, then a power 4, a power 2, a power 2, a power 4 is accepted. Okay, so this is a problem. And if I make it non final, then you can see a power 5 will be rejected. Yes or no? A power 5 will be rejected. So that is also a problem. Is this clear? Please tell me. Understood? Very simple. So remember, any two strings you can take. For example, if you take, let's assume a power 7, a power 19. Okay, a power 7, a power 19. Now tell me, is there any problem? If these two strings are going to same state, then is there any problem? Yes, again there is a problem. For example, consider what will happen from this state. If you, where you will go on a power 6, from this state q1, from this state q1, where you will go on a power 6, tell me. Okay, will you go to final or non final? Let me know. Will you go to final or non final? If you go to final, then problem. If you go to non final, then problem. Can you notice? If you go to final, then what is the problem? Tell me. If you go to final, if you make it final, then you can notice a power 25 accepted. A power 25 accepted. And if you make it non final, then a power 13 rejected. Is this clear? So problem. Did you understand? Please tell me. A student is saying a power 5, a power 11. So who will create the problem? Tell me. A power 5, a power 11. Tell me who is going to create a problem from this state q1. What will create a problem? Tell me. Anyone? A power, you can take. Tell me. A power 5, a power 11. Who will create a problem? A power 2. No, a power 2 will not create a problem. You can go to non final. This is also not accepted. This is also not accepted. A power 2 will not create a problem. Are you getting my point? See, if you take a power 2, this is also non final. This is also non final. So it is, I can make it non final. So no problem, right? I can make it non final. Give me something which will create a problem. Can anyone give me something which will create a problem? I want to create a problem. A power 7. A student is saying a power 7. No, a power 7 will also not create a problem. I can make it non-final. Yes or no? A power 7 will also not create a problem. Anyone? Anything else? Please suggest. Let me know. A power 6, a power 6. What about a power 6? Look at a power 6 here. Now if I make it final then problem, see, now if I make it final then problem, now if I make it non final then problem. Are you getting my point? See, if I make it final, okay, see, a power 6, you can take a power 6. Now you can notice, if I make this state final, then what will happen? Sorry, not a power 6. No, no, a power 6, no. A power 6, because if I make it a power 6, actually, just if I make it final, then no problem, right? Yes or no? Actually, if I make it final, then there is no problem. If I make it final, then there is no problem. No problem. Okay, so give me something. For these two, give me something. A power 7, no. Let me know. Give me some extension. See, some extension you give me such that problem will happen. Tell me. A power 19. I student is saying a power 19. So a power 24. No, this a power 19 will also not work. A power 10. A power 10 will also not work because this is also no. This is also not prime. This is also not prime. A power 20. Yes, 20 will work. Very good, very good. Excellent, excellent. 20 will work. Okay, because now you can notice. Now, if I make it final, then problem. Now, if I make it non-final, then problem. Notice, if I make it final, then what will happen? Then a power 25 is accepted. Yes or no? If I make it final, if I make this final, then a power 25 is accepted, which is a problem. Clear? Okay. And similarly, if I make it non-final, then also there is problem. If I make it non-final, then a power 31 rejected, which is a issue. Yes or no? So did you understand? Please tell me. So finally, this is the point. Remember, in this set S, this is an infinite set. In this set S, whatever two strings you take, if they go to same state, whatever two strings you take, if they go to same state in any DFA, then problem will happen. So this language is non-regular. Okay, is this point clear? This is the formal proof. I hope you understood. Is there any doubt? Anyone? Let me know. Let's solve this GATE 2001 question. So, which language is regular? The question has given four languages, and which of them is regular? So, tell me here. Let's look at the language L1. Language L1 is WW. This is non-regular. Yes or no? Language L1 is a non-regular. We have already seen in the previous lecture. If you want the formal proof why this is non-regular, if you want the formal proof, then that we have seen in the previous lecture, if you remember. Okay, the formal proof we have already seen in a previous lecture. Correct. Okay, what about the next one? WWR, where W is a binary string, WR is reverse of W. This also we have seen in the previous lecture. Yes or no? This is also non-regular, and the formal proof, if you want, then we have seen in the previous lecture. Okay, in the previous lecture, the formal proof we have seen. Okay, what about the remaining two? Let's see. 0 power 2i and 0 power I power 2, where I is an integer. Let's understand these two. What is L3? L3 is a 0 power 2i, where I is integer. But remember, in the theory of computation, the power the power can never be negative. Yes or no? Is this clear? In theory of computation, you know that power can never be negative. Okay, so actually it will mean that it is greater than equal to 0. Okay, is this clear? In the theory of computation subject, the string power, this can never be negative. This can never be negative. Okay, is this clear? So that is the reason. Remember, here basically it means that it is I greater than equal to 0. So tell me, what are the strings in this language L3? Write some strings in L3, then you will understand what is this language. So if I put I equal to 0, then what I will get? If I put I equal to 0, you know that any string power 0, that is epsilon. Any string power 0, that is epsilon. So you can see, if I put I equal to 0, I will get epsilon. If I put I equal to 1, then I will get 0, 0. If I put I equal to 2, 0 power 4. If I put I equal to 3, then 0 power 6. I, I equal to 4, 0 power 8. I equal to 5, 0 power 10. So what is this? This is even number of zeros. Yes or no? For this language, the regular expression I can easily write. The regular expression will be even number of zeros. That will be 0, 0 whole star. Because this regular expression I can write, so I can say L3 will be what? L3 will be regular. Yes or no? Very simple. Now let's see what is L4. Okay, in L4 we have I power 2. This is the L4. This is 0 power I power 2. See this, 0 power I power 2. Correct? Okay. So let's look at now 0 power I power 2. Now let's write some strings, then you will understand what is this language. Again, here I is integer. Basically, it means that I is greater than equal to 0, because in theory of computation subject, power can never be negative. Okay, yes or no? I told you W power n, this power n can never be negative. So basically, this I is greater than equal to 0. Okay, let's write some strings which are in the language. Tell me, for example, if I put I equal to 0, what I will get? If I put I equal to 0, then it will be 0 power 0, that is epsilon. Yes or no? You already know that any string, whatever string you take, that power 0 is always epsilon. If I put I equal to 1, what I will get? I will get 0 power 1. If I put I equal to 2, then what I will get? I will get 0 power 4. If I put I equal to 3, I will get 0 power 9. If I put I equal to 4, 0 power 16, 0 power 32, 0 power 64. Sorry, if I put I equal to 5, if I put I equal to 5, I will get 25. Sorry, 25. Okay, if I put I equal to 6, 36. Okay, then 49. Is this clear? And so on. Then there will be 64 and so on. Okay, I hope you understood. So this language, tell me, is this regular or not? This language is non-regular. Okay, this language is non-regular. Why this is non-regular? Because you can easily see there is no repeating pattern here. Actually, you can easily see there is non-uniform distance. Okay, there is no uniform distance between the consecutive strings. We have non-uniform distance. For example, here you can notice, here the distance is what? That is 5. What the distance here? That is 9. What the distance here? Tell me. Here the distance is 13. Yes or no? Is this clear? So you can see there is non-uniform distance. For example, here what the distance? That is 11. Okay, are you getting my point? Let me know. Okay, so like this, you can easily see there is non-uniform distance. Here 5, here 9, here 11, here 13. Okay, so this type of thing your finite automata cannot do. So this is non-regular. Is this clear? I told you that in any sequence, if you have non-uniform distances like this, in any sequence, if you have non-uniform distances, then that language is non-regular. If there is no repeating pattern, then language is non-regular. Yes or no? If you need some complex calculation, then your language is non-regular. Okay, is this clear? Please tell me. Understood? Is there any doubt? So you can easily see this is non-regular. So finally, the answer will be what? And this is regular. Okay, and the remaining two we have already seen in the previous lecture. These are non-regular. So finally, which language is regular? The question is asking. So only L3 is regular. Okay, answer will be option D. Now let's move on. Let's see which of them is regular, which of them is not regular. Tell me answer quickly. W is a binary string. This is already given to you. W is a binary string. So tell me. Here you can see A power n, B power n, where n is greater than equal to 10. Yes, this is non-regular. Okay, unlimited comparison, infinite possibilities of comparison. Okay, A power n, B power n is greater than equal to 10. So this is non-regular. What about the next one? Tell me. What about this one? A power m, B power n, where n is greater than equal to 10 and m is less than equal to 10. This is regular. There is no connection. There is no relationship between m comma n. Yes or no? Is this clear? There is no relationship between m comma n. This language, look at the language. Option B. Option B is saying, in option B you have, this is the language that is A power m, B power n, where remember n is greater than equal to 10 and m is less than equal to 10. Okay, is this clear? So can I say this is finite language? Let me know. This language, is this finite? First of all, there is no comparison. There is no comparison between m comma n. There is no comparison here. Okay, so easily you can easily see this is a regular. Okay, is this finite or not? Tell me. This is an infinite language, remember. This is an infinite language because you can see that this n is greater than equal to 10. Yes or no? N is greater than equal to 10. So what will be the regular expression for L? If this is regular, can you give me regular expression for L? Tell me. Anyone want to tell me the regular expression for L? Because if this is regular, then you should write regular expression. That is very easy. Remember, m is less than equal to 10. Okay, so if m is 0, then what I will get? If m is 0, tell me. Very simple. If m is 0, then what I will get? Then I will get b power 10, b power 10. At least b power 10 should be there. Yes or no? And then b star. Okay, b power 10, b star. Because remember, n is greater than equal to 10. So b power 10, b star. This will happen when, remember, this will happen when you put m equal to 0. Correct? When you put m equal to 0. Now, if you put m equal to 1, what you will get? If you put m equal to 1, m equal to 1, so that will be a. Then again the same thing, b power 10, b star. Okay, yes or no? Remember, this will happen if you put m equal to 1. Okay, or if you put m equal to 2, then it will be b power 10, b star. Is this clear? So this will happen if you put m equal to 2. And so on. At the last, what you will get? At the last, remember, m can be 10 maximum. M can be 10. So it will be like a power 10, b power 10, b star. Okay, is this clear? So I hope you understood. This is the regular expression for L. Very easily you can write. So this language is regular. What about this? M is not equal to n. This is non-regular. We have already seen in the previous lecture. The formal proof we have seen in the previous lecture. You can watch it. Okay, let's see the next. That is a power m, b power n, where both are odd numbers. This is regular. Yes or no? Because both must be odd number. A power m, b power n, where both are odd. Can you write the regular expression for it? See, the language is a power m, b power n, where m comma n both are odd. Okay, can you write the regular expression? Tell me. What will be the regular expression for this language? This language will be regular, so you must write regular expression. Okay, what that will be? You can see both are odd. Okay, it's like this. Double A whole star A. So this is your A odd followed by B odd. Remember, it's like this. A then B. Okay, after A, B should come. So you can see these are the odd number of A's followed by odd number of B's. Followed by odd number of B's. This is your regular expression. Okay, is this clear? Very simple. Because you can see, okay, A's followed by B's. Now let's see the next one. What about this? N is prime. A power n, n is prime. We have already seen this is non-regular. Okay, so that's it. Now let's move on. Tell me the answer for these questions. Which of them are regular? Which of them are non-regular? Here you can see WCW. WCW, where W belongs to AB whole star. This language is non-regular. We have already seen in the previous lecture, if you remember. It is like this. This is the middle symbol, right? Because here you must have W and here you must have W. Okay, agree? Okay, so this is actually the middle symbol. This is actually the middle symbol because here you have W, here you have W. Okay, both are W. On this side also W, on this side also same string. Okay, so that is the reason you can easily see this is non-regular. We have already seen the formal proof in the previous lecture. You can watch the previous lecture for formal proof of this language, why this is non-regular. But you can easily see there is comparison here. The middle symbol is C. So you can see this left part of C must match with the right part of C. Yes or no? Okay, this is the middle symbol. The left part of middle symbol should match with the right part of the middle symbol. So this is what you should do. So this is non-regular. What about the next one? Tell me. What about the next one? That is W is either A power M, B power N, or B power M, A power N. So this is regular. Why this is regular? Because this is just union of two languages. Okay, look at option B. Option B is basically union of two languages. It is like A star B star union, A star B star union B star A star. Yes or no? B star A star. This is your option B, because this is the union of two languages. Okay, is this clear? Option B, that is the union of two languages. So there is language, regular language, that is A power M B power N. Okay, and there is another regular language, that is a union B power M A power N. Okay, is this clear? So you can easily see that this is also regular, this is also regular. So union of two regular languages. So easily you can easily see that this is also regular. Okay, what about the next one? A power N, B power N, C power N. Okay, this is non-regular. Yes or no? There is a comparison here, unlimited comparison, because you can see N is greater than equal to 0. So here you have to compare. Okay, let's look at this option C, that is A power N, B power N, C power N. Okay, yes or no? This is actually more complicated than A power N, B power N. We have already seen this A power N, B power N, where N is greater than equal to 0. This itself was non-regular. Yes or no? This we have already seen. Similarly, you can easily see that this is also non-regular, because here you, what you need to do, remember, number of A must be same as number of B, must be same as number of C. Okay, if you have, for example, if you have 100 A's, then you must have 100 B's, you must have 100 C's. You must remember how many A's you have seen. The finite automata must remember how many A's we have seen, so that we can match with the number of B's, so that we can match with the number of C's. Okay, so your finite automata must remember exactly how many A's you have seen, whether you have seen 500 A's, maybe 10,000 A's. So we must remember exactly how many A's we have seen. Okay, is this clear? So that we can match with number of B, number of C. So this language is a non-regular. Okay, what about the next one? This next one, tell me, A power X, B power Y, C power Z, where all are greater than equal to 1. This is regular. You can easily write the regular expression. What that will be? The regular expression, tell me, the regular expression will be A plus B plus, that will be A plus B plus C plus. Yes or no? Because you can see greater than equal to 1. So A plus B plus C plus. What about the next one? That is A power N, B power M, A power N, where N is greater than equal to 10, M is less than equal to 10. What about this one? Please tell me. This is also non-regular. Okay, why this is non-regular? Let's see. This option E, you look at option E. This is saying A power N, A power N, B power M, A power N, where N is greater than equal to 10. Okay, M is less than equal to 10. This is the question. Now you can easily see this is actually non-regular. Why this is non-regular? See, if you put M equal to 0, what you will get? Or if you put M equal to 1, see, if you put M equal to 0, what you will get? Let me know. Because M is less than equal to 10. So if you put M equal to 0, what are you going to get? M equal to 0. So you will get A power 2n. That is fine. Okay, here there is no problem. Yes or no? You will get A power 2n. This is fine. But or, notice, notice this or. Here you notice what is happening. Here you notice that if I put M equal to 1, then what will happen? Then there will be B. And here you must have A power n. Here you must have A power n. This itself is your non-regular. Yes or no? Is this clear? Are you getting my point? Please tell me. Because you can notice this B, this is the middle symbol now. Because here you must have A power n, here you must have A power n. So remember, we should remember how many A's we have seen, so that we can match with A's. Yes or no? The finite automata must remember before this B, this is the middle B, before the middle symbol, how many A's we have seen, so that we can match with number of A's after the middle symbol. So you can see this itself is your non-regular language. Okay, this itself you cannot do. For example, if you put M equal to 2, then also you can easily see the same thing. Okay, B power 2, again there is A power n, A power n. Okay, so again you can see this, you can look at this is also non-regular. Okay, so basically it is a very simple point that M is less than equal to 10. Okay, maximum you can have some 10 B's, you can have maximum. Okay, here you can have at most 10 b's, but remember, before these you must have a power n, after these you must have a power n. So that is your non-regular. Is this clear? Please tell me, is this clear? Let me know. So very simple point, remember, in between you can have at most 10 b's. Okay, because m is less than equal to 10, so you can have at most 10 b's here, at most. Okay, but before that a power n, after that a power n. So this is a non-regular. Okay, very simple point. So I hope you understood all of them. So this question also we have done. Now let's move on. What about these two questions? Please tell me the answer. Which of them is regular, which of them is non-regular? Let's look at L1. What is L1? Tell me. Just understand the language. This is just 1 power to n. Yes or no? It is regular. Why? Because this is just 1 power to n, where n is greater than equal to 0. This is just even number of ones. So this is actually regular. Okay, understand the language. So in this language, basically, in this option A, if you look at option A, the regular expression you can easily write. The regular expression will be 1 1 whole star. Okay. What about option B? Tell me. What about that? That is non-regular. Okay, option B, that is a non-regular. Why this that is non-regular? Because in option B you can easily see we have this length, this language, that you have 0. And remember this 1 power m, 1 power n. The question is saying that m is greater than n. Okay, is this clear? So basically you can see this 0. Okay, the left of this 0, this must be greater than right of this 0. Okay, is this clear? So you can easily see that here there is comparison, there is unlimited comparison, infinite possibilities of comparison are there. So this language is a non-regular. Okay, easily you can see. Understood? Please tell me. Let me know. Okay, so very simple. Now let's move on. What about this language? Tell me, is this regular or not? A power n, b power n, c power n. A power n, b power n, c power n. This language is actually, this is finite language, so this is regular. Yes or no? Notice this is just a finite language. N is less than equal to 3. Every finite language is a regular. So this language is also regular. Okay, let's move on now. Now we will solve some most tricky questions on regular comma non-regular. Okay, so some most tricky languages we will see. Let me tell you, these are the most tricky languages you have seen so far, you will see so far. Okay, and we will see whether they are regular or not. So these languages we will see, let me tell you. For example, on your screen, all the languages that I will see. Okay, so we will see these languages like number of 0 1 equal to number of 1 0, number of 1 equal to number of 0. Okay, number of double 0 equal to number of 1 1. Okay, number of 0 1 0 equal to number of 1 0 1. Number of 0 equal to number of 0 1. Number of 0 1 1 equal to number of 1 1 0. So basically these languages we will see, and we will see which of them is regular, which of them is not regular. Okay, so these are very tricky languages, so you try to understand each of them. Okay, all these languages we will do the complete analysis, you try to understand. So first we will see these two languages. Okay, here you can notice I've given you two languages here. One language is D, another language is L. In this language, okay, the alphabet is 0 comma 1, remember the binary alphabet we have. And here you can notice in this language we have those strings which contain equal number of 0 1 and 1 0 substrings. Okay, is this clear? We want those strings W contains equal number of occurrences of substring 0 1 and 1 0. And in this language we have equal number of ones and zeros. Okay, so let's see which of them is regular, which of them is not regular. So tell me here, can I say both are non-regular? Let me know. Because we have comparison here, number of 1 should be equal to number of 0. Yes or no? And here also number of 1 0 should be equal to number of 0 1. So can I say there is comparison in both the languages? Yes or no? Both the languages have comparison. Here we have to compare number of 0 equal to number of 1. Here we have to compare number of 0 1 equal to number of 1 0. So can I say both are non-regular? What many students will do? Majority of the students, when they see comparison, in the language, what they will say? They will say non-regular. But you should first understand the language. Just wait and understand the language first. You are not understanding the language, you are not creating the infinite possibilities. I told you a language is non-regular if you can create infinite possibilities of comparison. If you cannot create infinite possibilities of comparison, then that language is regular. Okay, is this clear? For example, consider this language on your screen. Consider the language L. Now you tell me, this language is regular or not? In the previous lecture, we have already seen this language is a non-regular. Okay, see, here we have equal number of ones and zeros. Equal number of ones and zeros. Okay, so here you can see, can you create infinite possibilities of comparison? Tell me. Can anyone create infinite possibilities of comparison? Yes, I can create infinite possibilities of comparison. For example, if I have two zeros, let's assume if I have, for example, two zeros, then I should have two ones. If I have three zeros, I should have three ones. Okay, yes or no? This type of strings can I create? See, look at the strings I'm creating. For example, 0, 0, 0. Okay, then what I should have? Then I should have 1, 1, 1. If I have, for example, 0, 0, then I should have what? If I have 0, 0, then I should have 1, 1. Okay, if I have 4, 0, then I should have 1, 1, 1, 1. Okay, yes or no? And so on. Is this clear? Okay, and so on. So these are the infinite possibilities that I can create. Do you agree with me? Okay, infinite possibilities I can create. If I have 3, 0, then 3, 1, 2, 0, 2, 1, 4, 0, 4, 1, 100, 0, 100, 1. Yes or no? I can create this type of situation also. For example, 100, 0, 100, 1. Okay, yes or no? I can create 100, 0, 100, 1. 1000, 0, 1000, 1. 1 crore 0, 1 crore 1. So like this, these are the infinite possibilities I can create. Because I can create these infinite possibilities of comparison, so that is the reason this language is a non-regular. Okay, is this clear? This language is a non-regular. Understood this? Okay. One more thing, you look at this language. In this language, one more thing. Tell me, in any string 0, comma 1, are they dependent on each other? Can they freely occur without disturbing the other? Tell me. See, in this language, we want equal number of 0, comma 1s. Okay, look at any string. Is it possible that 0, comma 1 they are completely independent? Can I say they are completely independent? Can I say they are independent of each other? Means one of them do not disturb the other. Yes, they don't disturb each other. For example, if you want 10, 0, you can have it. See, if you want 4, 0, you can have it without anyone. Okay, is this clear? If you want 6 ones, you can have it without any 0. If you want 2 more 0, you can have it without anyone. If you want 4 more ones, you can have it. If you want 3 ones, you can have it. Are you getting my point? Okay, so they are completely independent. Is this clear? That is the reason infinite possibilities we can create, because they are independent. So we can create infinite possibilities. So we can create infinite possibilities of comparison because they are independent. So what infinite possibilities I can create? I can create these infinite possibilities, like for example, I can have 0 power 100, 1 power 100. Yes or no? I can create, for example, 0 power 1000, 1 power 1000. Okay, like this. Okay, because they are completely independent of each other. You can, whatever number of 0 you want, you can have it. Okay, without having any one. For example, this string you can have. You don't need any one. So this is the point. So you have infinite possibilities of comparison because they are independent of each other. Now let's see this example, this language. The alphabet is binary alphabet, and we want strings which have equal number of occurrences of substring 0, 1 and 1, 0. They must be equal number. So can I say there is comparison here? Some students, what they will think, sir, I want, you want comparison. Okay, yes or no, you want comparison. So we have to count how many zeros we have. See, we have to count how many 0 ones we have seen. Number of 0 ones, that should be equal to number of 1 zeros. So we have to count how many 1, 0 we have seen, how we have to count how many 0, 1 we have seen. So there is comparison. Do you agree? Yes or no? This we have to count how many 0, 1 we have seen, how many 0, 1 we have seen, we have to count how many 1, 0 we have seen, that we have to count. So there is comparison. Okay, so can I say, that is the reason, can I say this language is non-regular? Can I say no? Let me tell you no. What is the reason? Let me tell you the reason. The reason is actually very interesting. You will find this very interesting because actually they are not independent of each other. Okay, they actually influence each other. Or I can say one of them cannot come without another. It's like, have you seen that movie? There is a Shahrukh Khan Salman Khan movie, Karan Arjun. In that movie there is a dialogue, Karan आया तो Arjun भी आएगा. If Karan has come, then Arjun will also come. Okay, these are actually Karan Arjun, let me tell you. Okay, these are actually Karan Arjun, let me tell you. This 1001, they are actually Karan Arjun. Let me tell you why. Okay, see, can you bring two two occurrences of 0 1 without any 1 0? Is it possible? Just try. Just try. Okay, just try to bring this type of situation where you have two occurrences of 0 1, you have 2 0 1 string. I am asking that you do this. That number of 0 1 string is 2 and number of 1 0 string is 0. Is it possible? Create this type of string. Create this type of string. Okay, let me create this type of string where you have 0 1 is coming two times, but 1 0 is not coming. 1 0 is not coming. Can you create this type of possibility? Tell me. Let me know. See, in the previous language, where you have equal number of 0 comma 1, where you have equal number of 0 comma 1, here can you create this type of possibility that number of 0 is 3 and number of 1 is 0? Can you create this type of string? Yes, I can create. This string I can create. Do you agree? Because they are independent of each other. Oh, yes or no? 0 comma 1, they are independent of each other. This string I can create. Here I have three zeros and there is no 1. But now look at this one. Can I create this type of string where I have, there is 2 0 1 but there is no 1 0? Okay, let's try to create. Let me try to create. I want 0 1. This 0 1 I want. I want another 0 1, but I don't want any 1 0. Okay, so I want, okay, can I take this? Can I take this? No, I got 1 0. Can you see I got 1 0? See, if you want 0 1 two times, if you want 0 1 two times, then you will also get 1 0. Okay, let's try. Let's try to make sure that we don't get 1 0. Okay, so can I do something? For example, I got 0 1. Let's assume I got 0 1. I don't want 1 0, but I want 2 0 1. Okay, I want another 0 1. So can I put something in between? For example, can I put something in between? Can I put some, okay, because here I got 1 0. I don't want 1 0. So can you help me? Can you put something such that I will not get 1 0? I don't want 1 0. So what can I put such that I will not get 1 0? If I put 1, I will get 1 0. If I put 0, I will get 1 0. Are you getting my point? Whatever you do, if you have 2 0 1, then you will definitely have 1 0. Did you understand this? Let me know. Okay, tell me. So you can easily see that this type of string is never possible. Okay, you can just try to create because you can easily see. Okay, I have 0 1. Okay, I want 2 0 1. Remember, I want 2 0 1, but I don't want 1 0. I don't want 1 0. So here, in between, what can I put? Tell me. In between, what can I put? A student is saying, sir, put 0 1 0. Let me put, okay, okay, okay. Let me put. Now also, you got 1 0, you got 1 0, 2 1 0 you got. C 1 0, C 1 0, 2 1 0 you got. And how many 0 1 you got? 3 0 1 you got. Okay, is this clear? Understand? So this is what I'm saying, that this type of situation, see, this type of situation you cannot create. Okay, that you have 2 0 1, but there is no 1 0. You have 2 0 1, but there is no 1 0, because whatever you put here, you will get this 1 0 you are getting. So remember, this is not possible. No such string possible. Understood this? That there is no such string possible. Okay, so let me tell you one thing. If you create some strings, you will understand this, that see, 0 1 comma 1 0, they are coming. If 2 0 1 are coming, remember, if 2 0 1 are coming, then 1 1 0 will also come. Okay, is this clear? You can see. Okay, remember, the strings will happen like this. Only three situations you can create. Either you can create this situation where there is equal number of 0 1 and 1 0. Only three situations are possible. Remember, considering number of 0 1 comma number of 1 0, considering them, only three cases are possible. Only three possibilities are there. We don't have infinite possibilities. Only three possibilities are there. What are those three possibilities? Tell me. Those three possibilities are either both are same, means number of 0 1 is equal to number of 1 0. Either this possibility is there, or number of 0 1 is one more than number of 1 0. Only one more than that. Only one more than that. Or number of 0 1 is one less than 1 0. Is one less than 1 0. Only these three possibilities are there. Did you understand this? Please tell me. Whatever string you create, you can check it. For example, if I create this string like 0 1 0, okay, in this string, how many 1 0 I got and how many 0 1 I got in this string? In this string, number of 0 1 is 1 and number of 1 0 is that is also 1. Yes or no? 0 1 is 1 and 1 0 is 1. Please tell me, did you understand? Both are 1 1. And for example, if I create this string 0 1 0 1, here you can notice that number of 0 1 is 2 and number of 1 0 is 1. So you can see that is 1 more than, okay, there is difference of 1. Yes or no? Is this clear? So this is what I'm saying, that either they will be same, either they will be same, or I can say there are two possibility. I can say there are two possibility, or you can consider three possibility. Don't worry. Basically, either they will be same or they will have difference of 1. Okay, they will have difference of 1. Is this clear? This and this will have difference of 1. Please tell me, is this point clear? Okay, is this clear? So remember, either this will happen, that both are same, number of 0 1, number of 1 0, both are same, or number of 0 1 is 1 more than number of 1 0, or number of 0 1 is 1 less than number of 1 0. Only these are possibilities, nothing else is possible. Whatever string you create, for example, if I create this string 1 0 1 0, here number of 1 0 will be 2 and here number of 0 1 is 1. So again, there is only difference of 1. Whatever string you create, okay, just let me create, okay, some random string I am creating. Randomly I am writing. I promise you, randomly I am writing. You can also write. Randomly you can write something. Okay, so tell me, how many 0 1 are there? In this, how many 0 1 are there? These white ones are the 0 1. 0 1 0 1 0 1 0 1 0 1 0 1. Okay, these are the white ones. So how many? Total 6. Yes or no? And how many 1 0 are there? How many 1 0? Tell me. You can see this is 1 0, 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 and this is 1 0. So tell me, how many 1 0? Again 6. So they are same. Yes or no? This is what I am saying, that number of 0 1 and number of 1 0, either they will be equal or there will be only difference of 1. That's it. That's it. Okay, only these are the possibilities. Nothing else is possible. Is this clear? Please tell me. So only these things are possible. Is this clear? Please tell me, did you understand? So now let's see. Now let's see what will be the regular expression. Actually, this language will be regular, but what type of strings we will have? Okay, just try to understand. This is actually very simple. So your alphabet is what? That is 0, 1. And what we want? We want that number of 0, 1. This should be equal to number of 1, 0. Now something very interesting I am going to tell you. See, this 0, 1, if you look at, okay, this is what we want. Yes or no? That they must be same. This is what we want. Okay, now you just see. Look at this 0 1. In this 0 1, can you notice we are switching? Yes or no? Let's call it switch. We are switching, right? Okay, let me call it switch up. Let me call it up. So you tell me, if I want both equal, number of 0 1 and number of 1 0, if I want both equal, then how many up I have? The same number of down I should have. Do you agree with me? Do you agree with me? The same number of down should I have? Yes or no? I should have down also. Is this point clear? Please tell me. Can I call it switch down? So how many up I have? The same number of down should I have? If I want this, then the number of up, the number of switch up, I can say the number of switch up, okay, that should be equal to the number of switch downs. Do you agree with me that how many switch up we have? Because how many 0 1 we have, that means switch up. Yes or no? How many 0 1 we have, that means switch up. Okay, this means up. So how many 0 1 we have, that should be equal to how many 1 0 we have, that is switch down. So switch up, that should be equal to basically up equal to down. Yes or no? Okay, so now you tell me a very simple question I'm asking you. Just tell me, you already understood that this is up. Okay, let's call it up. And this is down, let's call it down. Okay, so you understood one thing, you agree with me that number of up should be equal to number of down. Okay, this you agree with me, that number of up, this should be equal to number of down, they should be same. Okay, so just tell me this point. If my string is starting with 0, then tell me one point. It should, can it end with 1? Is it possible? Just think about it. Very simple question I'm asking. If my string is starting with 0, can it end with 1? Can it end with 1? Just take your copy pen. Take your copy pen. Try. If my string is starting with 0, can it end with 1? See, it cannot end with 1. Why? What is the reason? Because how many up should be there? That should be equal to down. See, if this is the up, then I need a down. Yes or no? Notice. See, if my string is starting with 0, let's try to end with 1. I want to end with 1. Okay, remember, I want to end with 1. So please understand, if my string is starting with 0, I can have any number of 0. So far, everything is fine. Do you agree? If my string is starting with 0, okay, let's assume my string is starting with 0. Okay, so now you tell me, if I have any number of 0, that is fine. So far, there is no problem. But if I do up, then I need a down. Yes or no? Then I definitely need a down. Remember, if I put, for example, 1 1 1 1, still I need a down. I need a down. Okay, yes or no? So I need a down. Okay, so you can see, if I'm starting with 0, then I'm ending with 0. Now you might be thinking, then sir, maybe I will put another one. Okay, because if I'm starting with 0, then let me end with 1. So let's assume you are putting some more 0 and then you are putting 1, because you are making this, that if you start with 0, you are trying to end with 1. Okay, try your best. You start with 0, try your best to end with 1. Then what will happen? Another up is coming. Another up has come. So another down should come. Yes or no? Another down should come. So whatever you do, you will end with 0. Is this clear? Please tell me. Whatever you do, you will end with 0. Yes or no? Please tell me. Understood this? Let me know. So this is the point. And the same thing you can see. If I start with 1, then can I end with 0? Just think about it and tell me. If I start with 1, I am starting with 1. This is fixed. Okay, now is it possible that I can end with 0? No, it is not possible, because you can easily see. See, after this one, if I can put any number of ones, so far everything is fine. This string is fine. This string is accepted. This string is in the language. Everything is fine. But just notice, if I bring 0, means this is down. If down has come, then up will come. Okay, yes or no? Because I want number of 0 1 equal to number of 1 0. So how many up? That should be equal to how many down? So remember, if I have this down, I need a up. I definitely need up. So if I put 0 0 0 0, still I need up. I need up. Yes or no? If I need up, then 1 will definitely come. Okay, yes or no? Now you can easily see. If you think that, okay, sir, I'm starting with 1, I will try my best to end with 0. But you cannot do that, because remember, if you put any number of ones, and let's assume you try to end with 0, this is what you want. You want to end with 0. But remember, now you have another down, so you need another up. Yes or no? You need another up. So this is what I'm saying. If you start with 1, then you will end with 1. So what is this language? Can you tell me? Let's write the regular expression. Basically, this language is, okay, let me write. This language is very interesting. Okay, I can easily write the regular expression for this language. The regular expression will be, that will be, remember, any number of 0 are coming, I have no problem. Yes or no? These strings should be accepted or not? Tell me. These strings which only contain 0, no 1, these strings should be accepted or not? Yes, these strings should be accepted. These strings also should be accepted, right? Yes or no? Here there is no 1. These should be accepted. Here there is no 0. These should be accepted. Okay. So what about the remaining? What about the remaining? The remaining will be like this. If you start with 0, you should end with 0. And if you start with 1, you should end with 1. Is this clear? Please tell me. If you are starting with 0, you should end with 0. If you are starting with 1, you should end with 1. Please tell me, did you understand? Let me know. So this is the regular expression. Let me know, did you understand this point? Because remember, if you start with 0, you cannot end with 1. If you start with 1, you cannot end with 0. Okay, so if you are starting with 0, you will end with 0. If you are starting with 1, you will end with 1. Okay, and one more interesting thing. See, if you take this type of string, then in between whatever you do, number of up down will be same. Can you prove it? I am saying, I am saying that between these two zeros, whatever you do, number of up down will be same. Can you prove it? See, between these two zeros, this is the first and this is the last. This is the first and this is the last. Between these, whatever dance you do, you can do any dance. The number of up down will be same because you can easily see number of up down will be same because if you do up, remember still the end symbol is 0, so there is down. Yes or no? If you do up, then you can easily see there is down. Okay, for example, let's assume you do. Okay, if there is up, then can you bring another up? After up, can you bring another up? Tell me, is it possible you can bring two up simultaneously? After up, can you bring up? Tell me, please tell me. After up, can you bring up? No, you cannot bring. Yes or no? After up, definitely down will come. Yes or no? Is this clear? So very simple point. This is what I am saying. That whatever you do, up down will be same. Okay, see, very simple point. Just try to understand this. I am saying that these are the observations. These are the observation. Remember, number of 0 1 equal to number of 1 0. Number of 1 0. Some observations I am telling you. Okay, just tell me whether you are understanding the observations or not. So the first observation we got, the first observation is that if you start with 0, then you cannot end with 1. Yes or no? If start with 0, okay, then cannot end with 1. If you start with 0, then cannot end with 1. Yes or no? This was our first observation, that if you start with 0, then you cannot end with 1. The second observation was, if you start with 1, if you start with 1, then you cannot end with 0. Okay, the third observation, 2 up cannot come simultaneously. Yes or no? 2 up cannot come simultaneously. 2 up cannot come simultaneously. Yes or no? Back to back. Or I can say consecutively. 2 up cannot come consecutively. Do you agree? And similarly, remember, 2 down cannot come consecutively. Okay, is this clear? 2 down cannot come consecutively. 2 down cannot come consecutively. Okay, is this clear? Simple. Because remember, if, okay, is it possible? See, just look at this. Is it possible that 2 up can come simultaneously? See, this is a up. See, this is a up. Can you bring another up? Okay, after this up, without any down. Without any down, can you bring another up? Can you bring another up? See, can you bring another up? No, there is a down here. There is a down here. Yes or no? Is this clear? This is what I'm saying, that 2 up cannot come simultaneously. There will be a down in between. Similarly, 2 down cannot come simultaneously. This is a down, this is a down. These are down, down. But you can see in between this up has come. Or I can say, for example, if you put, for example, 0 0 0, whatever you do, there is a up has come. Again, up has come. Yes or no? So remember, 2 down cannot come simultaneously. Between up will come. Now you can easily see, if you start with 0 and with 0, then remember, if up will come, then down will come. Yes or no? Agree? If up will come, then down will come. Because remember, if 2 up are coming, then definitely between down will come. And remember, if up has come, then at the end there is 0, so there is down. So this is the point. I hope you understood. This is not a hard point. I'm saying that if you start with 0, if you end with 0, and let's assume because you are starting with 0, so what the first thing can come? Tell me. A simple thing. If you are starting with 0, then the first thing will be up or down. Tell me, if you are starting with 0, then first thing will be up or down. Let me know. The first thing, the first activity will be up or down. If you are starting with 0, then first activity will be up. And tell me, if you are ending with 0, then the last activity will be down or up. If you are ending with 0, if you are ending with 0, then the last activity will be up or down. That will be down. Now you can easily see there is up, there is down. Two up cannot come simultaneously, so down should come. Now two down cannot come simultaneously, so up should come. So you can see number of up and down is equal to same. Yes or no? Similarly, if you end with 1 and if you start with 1, then whatever dance you do in between, you can in between whatever you do, you can do any dance. You can do any dance in between. Remember, number of up down will be same. If you start with 1, if you end with 1, then whatever dance you do in between, then number of up down will be same. I hope you understood this is the complete analysis and this will be the regular expression. Is this clear? You can see starting with 0, ending with 0, starting with 1, ending with 1, or there is no 1 or there is no 0. Okay, so this is the regular expression. That's it. Please tell me, did you understand? Let me know. This is the complete analysis of this question. So finally, I can say this language is regular. Is this point clear? Please tell me. Remember, number of 10 equal to number of 01. This language is regular. But did you understand what the reason for regular? Why this language is regular? Did you understand the reason? The reason is because they are dependent on each other. Yes or no? These two, if you look at these two, they are dependent on each other. If one of them is coming multiple times, then another is also coming. Basically, one of them cannot come freely without another. Okay, one of them cannot come freely without another. If this is coming two times, then this is at least coming one time. Okay, is this clear? Means this cannot come freely, keep coming freely without this. It cannot happen. Similarly, this cannot keep coming freely without this. So they are actually dependent on each other. Dependent. Okay, is this clear? If one comes, another will come. If one repeats, one cannot repeat. One of them cannot repeat without another. Is this clear? Let me write this. One of them cannot repeat, cannot repeat without another. Without another. Okay, is this clear? Please tell me. This line is very important. This 1001, one of them cannot repeat without another. Okay, or you can understand that movie. Karan aaya to Arjun bhi aayega. These are like Karan Arjun. Okay, there is a movie. There is a Bollywood movie, Shahrukh Khan, Salman Khan movie. There is a movie that is basically Karan Arjun movie. In that movie, there is a dialogue. If Karan has come, then Arjun will also come. Karan aaya to Arjun bhi aayega. So these are basically Karan Arjun. These two people. Okay, so that is the reason you can see one of them cannot repeat. One of them cannot repeat without another. Okay, so this language is regular and we have seen the regular expression for this language. I hope you understood. Now let's move on. Let's see these two languages. Okay, so this we have already seen. You can see this is the regular expression we have already seen for this language. Number of 01 equal to number of 10. Now let's move on. Let's see these two languages. Tell me which of them is regular, which of them is non-regular. Take your copy pen. Very interesting question. This is very interesting question. So tell me, the first one, is this regular? Let's see. The first one is saying that number of 00 equal to number of 11. Remember, in this string, how many 00 are there? Tell me. In this string, how many 00 are there? In this triple zero, how many 00 are there? There are two double zero. Okay. Now, anyway, you tell me, these two are dependent or not? Can this repeat without this? Can this repeat freely? Can this repeat freely without this? Yes. Can this repeat freely? Can this repeat freely without this? Yes. They are independent of each other. Yes or no? Okay, look at option C. First, I am discussing option C. In this option C, basically that is L3. Here we have that number of 00. This should be equal to number of 1 1. Okay, yes or no? There is comparison here and they are independent of each other. So this language is non-regular. Is this clear? This language is non-regular. Why? Because you can easily see, first of all, there is comparison. We have comparison. Also, they are independent of each other. They are independent. They are independent of each other. For example, you can see that one of them can repeat without another. For example, okay, this zero can repeat. How many double zero we have seen here? One, two, three, four, five. Yes or no? Here you can notice that in this string you can notice how many double zero we have. Number of double zero is equal to 5. And number of 1 1, how many 1 1 we have seen? That is 0. Is this clear? So this is what I am saying, that in this language, okay, please focus on this language L3, that is number of 0 0 is equal to number of 1 1. Here you can easily see they are independent. They are independent, okay, of each other. They are independent of each other. And there is comparison. And we have to compare how many 0 0 we have seen, how many that we have to count, yes or no? There is a comparison. So you tell me one thing. Do we need to remember how many 0 0 we have seen? Let me create infinite possibilities. I can create infinite possibilities for comparison. What are those? For comparison. Infinite possibilities for comparison. What are those? See, I will create infinite possibilities and these are like this. I have to remember how many 0 0 I have seen. For example, I can have double zero. Here I can have one double zero. Okay, here I have two occurrences of double zero. Here I have three occurrences of double zero, four occurrences of double zero, and so on. Yes or no? Is this clear? Please tell me. So you can notice that these are the infinite possibilities, and I have to remember. Tell me one thing. Just tell me one thing. Let's assume this is a finite automata. Okay, this is finite automata, and okay, here we are just seeing 0 0 0 0 continuously, 0 0 0 0 0 0 0. Okay, so should we remember how many 0 we have seen? Should we remember that? Should I remember how many 0 I've seen? Basically, how many double zero I've seen? Should I remember how many double zero I've seen? Yes, I should remember this. Yes or no? How many double zero I've seen? I should remember number of double zero. Agree? I should remember number of double zero so that I can match with the number of 1 1, because maybe in future 1 1 will come. Okay, so that I can match. I can match with 1 ones to match with 1 1. So I have to remember number of double zero to match with 1 1, to match with the number of 1 ones. So that is the reason, remember, this language is a non-regular. Okay, because I have to remember, and there is arbitrary number of 0 0 can come, any number of double zero can come. I have to remember them so that I can match with the number of double ones. So that is the reason this language, remember, we have seen this language is non-regular. Okay, is this clear? This is a non-regular. Okay, what about the next one? What about L4? Tell me. L4 is saying number of 0 1 0 equal to number of 1 0 1. Tell me about L4. L4 is saying number of 0 1 0 is equal to number of 1 0 1. Are they Karan Arjun? Tell me, these two people, are they Karan Arjun? Let me know. Can one of them repeat freely without another? Tell me. Let me know. Can one of them repeat freely without another? Or are they dependent? Please tell me. Okay, just see some students what they will do. Okay, notice some students what they will do. They will do this. Okay, this 0 1 0. Okay, let me write it two times. Let me write it immediately. Let me write it immediately two times. Okay, so 0 1 0 has come, 0 1 0 has come. Okay, in between there is no 1 0 1, right? Yes or no? So actually 0 1 0 equal to 1 0 1. 0 1 0 equal to 1 0. Yes, there is no 0, there is no 1 0 1. Yes or no? 0 1 0 0 1 0. If I write it two times, then there is no 1 0 1. Yes or no? So actually they are independent. Is this point clear? Notice one thing, very simple. See, here there is no 1 0 1. Yes or no? For example, if I write another 0 1 0. Okay, now notice here what will happen. Look at this one. Look at this. Okay, for example, if I write another 0 1 0, look at this one. Now you tell me, in this string, how many 0 1 0 we have seen? In this string, tell me, in this string, how many 0 1 0 we have seen? Number of 0 1 0, that is 3, that is 4. Number of 0 1 0 0 1 0, that is 4. And how many 1 0 1 we have seen? Tell me. How many 1 0 1 we have seen? That is 0. So they are independent or dependent? Tell me. They are independent or dependent? They are independent. Yes or no? Is this clear? So this language is non-regular. Can one of them repeat freely without another? Yes. Yes or no? One of them can repeat freely without another. Do you agree with me? Okay, so remember these are, remember this 0 1 0, this, and this 1 0 1, this. They are basically independent. Okay, is this clear? They are independent. One of them can repeat freely. One of them can repeat freely without another. Okay, you can easily see. I can repeat, for example, I can repeat this 1 0 1. Okay, let me repeat this 1 0 1. Here you can notice there is no 0 1 0. Is this clear? Okay, notice what I can do. Here you can notice 1 0 1, there is 1 0 1. Okay. Next, there is 1 0 1. Next, there is 1 0 1. Okay, is this clear? Please tell me. So you can easily see here what is happening. Okay, another maybe 1 0 1. Okay, in this string, look at this string and tell me how many 1 0 1 we have seen. This is 1 0 1, 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 this is 1 0 1. So in this string, if you look at how many 1 0 1, that is 5. And how many 0 1 0? How many 0 1 0? That is 0. So they are independent. Do you agree? Yes or no? Is this clear? So I can say that they are independent and there is comparison. So this is non-regular. Please tell me, did you understand? So this 0 1 0 and 1 0 1, remember these two are independent. Independent. Okay, and there is comparison. Yes or no? And we have comparison. Independent comparison. There is independent comparison. So that is the reason I can say that this is non-regular. Okay, is this clear? This language will be non-regular. Why this is non-regular? Because we have to remember how many 1 0 1 we have seen. Yes or no? How many 1 0 1 we have seen, we have to remember so that we can match with the number of 0 1 0. A student is saying, sir, what about this case? See, a student is saying, sir, what about 0 1 0 1 1 0 1? I am asking, can you repeat it without coming without this? I am not saying that there is no string. For example, here also, okay, see, are they dependent or not? Number of 0 equal to number of 1. Are they dependent or not? Please tell me. Please tell me, are they dependent or not? Hello, Shiva? Please tell me. They are not dependent. But what about this string? But what about this string? But what about this string? So are you getting my point? I'm saying that, see, I'm saying, can you create a case where one of them can repeat freely without another? Please understand. Can you create a string where one of them can repeat without another freely? Here you can notice this 0 can repeat without this 1 freely. So we have to remember how many zeros we have seen so that we can match with the number of ones. That is the reason this is non-regular. Is this clear? Please tell me. Did you understand? Let me know. Please tell me. Okay. So this is what I'm saying. Did you understand that here? Remember, this I can repeat. I can repeat without this. Okay, any number of times. I can repeat this 0 1 0. I can repeat this. Okay, for example, look at this 0 1 0, then some extra 0 I will put, then 0 1 0, some extra 0 I will put, then 0 1 0, some extra 0 I will put, then sorry, some extra 0 I will put, then 0 1 0, some extra 0 I will put, 0 1 0, some extra 0 I can put, 0 1 0. Okay, like this. You can notice without this I can repeat. Okay, is this clear? So this is what I am saying, that you have to remember how many 010 you have seen, so that you have to remember this, so that you can match with the number of 101. So this cannot be done by finite automata. This is non-regular language. Okay, is this point clear? Please tell me. So finally I can say, in this question what will be the answer? For this question the answer is both are non-regular. Okay, is this clear? Both are non-regular. Okay, so now let's move on. Let's see this question. This is very interesting question. Tell me, if I ask you number of 0 equal to number of 01, number of 0 is equal to number of 01. So tell me here, let me know. This language is regular or not? This language is regular or not? Number of 0 is equal to number of 01. In which string this will happen? In which string this will happen? Tell me. Let me know. In which string this will happen? This language is regular. This language is regular. Why? Because already they are dependent. They are dependent. If 01 is coming, already the 0 is coming. See, they are dependent, right? If this 01 is coming, already in this 01 itself there is 0. In this 01 itself is there is 0. This 0 is itself is here. Okay. In this 01 already there is 0. Are you getting my point? So very simple point, that if this 01 is coming, then already 0 is coming with it. Okay, so see, understand this point, that here basically can I say that if 01 is coming, just think about it and tell me, if 01 is coming, if 01 is coming, then already three zeros have come. See, if 301 are coming, 301 has come, 301 has come, 301 has come, so automatically three zeros have already come. Yes or no? Is this clear? Please tell me. If you bring 301, if you bring 301, then automatically 30 have already come. And how many zero we want? How many zero we want in the question? That should be equal to number of 01. So can I put another extra zero? Can I put another extra zero? Can I put another extra zero? No. So are you getting the point? Remember, if n01 has coming, please understand, if n01 are coming, then automatically n zeros are all automatically coming. Is this clear? Because you can notice that automatically these zeros are already coming. So here, tell me what will be the language here. In this, the language will be, remember, if 01 is coming, no extra zero can come. Basically, here, okay, no extra zero can come. The zero can come only with 01. See, this string is allowed or not? Just tell me this point. This string is accepted or not? This string, does it belong to the language? No, it does not belong to the language, because remember, number of 0 should be equal to number of 01. Number of 0 should be equal to number of 01. So tell me, in this language, if you notice, can I say other than 01, no extra 0 can come? Is this observation clear? Other than 01, other than this person, other than with this person, no extra 0 can ever come. No extra 0 can ever come. Please tell me, is this point clear? No extra 0 can ever come. Means I can also say, in this language, can I say that if 0 is coming, then immediately after this 1 will come? Yes or no? If 0 is coming, then it is part of 01. Okay, is this clear? If 0 is coming, it is part of 01. Please tell me, did you understand? So what will be the language here? Can you write the regular expression? 1 can repeat freely. Do you agree? See, 1 can repeat freely. One can come any number of times. You already know one can come any number of times. If 0 is coming, then it will come as a 0 1. If 0 is coming, it will come as a 0 1. One can repeat any number of times. If 0 is coming, it will come as a 0 1. One can repeat any number of times. If 0 is coming, it will come as a 0 1. One can repeat any number of times. Okay, is this clear? So finally the regular expression is one can repeat freely. If 0 is coming, it will come as a 0 1 whole star. Is this clear? This is the regular expression. Please tell me, did you understand? Because if 0 will come, it will come as a part of 0 1. This is what we have seen. If 0 is coming, then it is coming as a part of 0 1. Okay, please tell me. So finally I can say this is my regular expression. Understood this? Please tell me. Okay, so very simple. What about this language? Number of 011 equal to number of 110. What about this one? Please tell me. Let me know here. Number of 011 equal to number of 110. Are they independent of each other? These two, are they independent of each other? Can I repeat this without repeating this? And can I repeat this without repeating this? Okay, it should happen both ways. See, in the previous question, a student is asking, okay, in this question, number of 0 equal to number of 0 1. In this question, a student is asking, sir, I can repeat zeros without any 0 1. Yes or no? Sir, I can repeat zeros without any 0 1. Okay, but it should happen two ways. Means, can you repeat it without it? Are you getting my point? See what I am saying. See, can you repeat this 0 1 without 0? Can you repeat this 0 1 without 0? Can you repeat this 0 1 without 0? Is this point clear? Please tell me. Some student was asking this doubt that, sir, I can repeat this 0, okay, without this 0 1. That is fine. That is fine. But can you repeat this 0 1 without 0? So they are dependent, right? Is this clear? So they are dependent. Please tell me. Understood? Is this point clear? Okay, because you can easily see in this 0 1 itself, if 0 1 will come, already the 0 has already come. This 0 has already come. Okay, so very simple. If you want number of 0 equal to number of 0 1, then remember the answer will be 1 or 0 1 whole star. Okay, because 0 cannot come freely. Okay, is this clear? In this language, if you want number of 0 equal to number of 0 1, then remember this will be your language, 1 or 0 1 whole star. Please tell me, is this doubt clear? Let's see this one. Please tell me the answer for this question. Number of 011 equal to number of 110. What about this one? Are they dependent? Can you repeat it freely without this? And can you repeat it freely without this? Just try. Okay, let me try my best. I will try my best. So for example, let me try this 011. I will repeat it without 110. I don't want 110. I got 110, but I don't want. So something can I put in between? See, this is 011, this is 011. Now I got 110. I got 110. So okay, can I put something in between? Give me something in between? Can I put, for example, if I put 1, will it work? If I put between these two, if I put 1, will it work? No, it is not working. Again I got 110. Yes or no? 1 is not working. I again got 110. Yes or no? I got 110. Okay, so will 0 work? No, 0 is not working. I again got 110. Is this point clear? Please tell me. So this, did you understand that? If you repeat this 011, then definitely, notice, if you repeat this 011, then definitely whatever you put, here you can put 0 or 1, whatever you put, okay, you can notice I cannot stop 110. If I put 0, I got 110. If I put 1, I got 110. Okay, is this point clear? Please tell me. Let me know. Okay, and what about the next? What about the next one? For example, what about, can I repeat this 110? Can I repeat this 110, 110? I don't want 011, but I got 011. Something can I put in between? Can I put something in between? For example, can I put 0? Again, I got 0, 1, 1. Can I put 1? Again, I got 0, 1, 1. Okay, is this point clear? So they are dependent on each other. Please tell me, did you understand? Let me know. So they are completely, totally dependent on each other. Okay, actually, how many situations are possible? Only three possibilities are there. What are those? Tell me. Only three possibilities are there. What are those three possibilities? One possibility is, see, only three possibilities are there. The first possibility is number of 011 is equal to number of 110. Another possibility is number of 011 is equal to number of 110 plus 1. Okay, is this clear? Number of 110 plus 1. And third possibility is number of 011 is equal to number of 110 minus 1. Only these three possibilities are there. That's it. Okay. Please tell me, did you understand? So this is a regular language. Okay. Is this point clear? This is a regular language. Simple. Now let's move on. So I hope you understood everything so far. In this session, whatever we have seen so far, did you understand? Please tell me. Okay, so we started with this example, that number of 0 1 equal to number of 1 0. This was also regular. Yes or no? This was also regular, and the regular expression we have already written for this. Okay. Now, one interesting variation I want to ask. See, a very interesting variation. Are you ready for it? Let's see. Very interesting variation is coming on your way. In this question, we have already seen that this was regular, right? When your alphabet is 0 1, then number of 0 1 equal to number of 1 0. This was regular, correct? Okay, this thing was regular, if you remember. And we have written the regular expression. What was the regular expression for this? The regular expression was 0 star or 1 star or 0 sigma star 0 or 1 sigma star 0. Okay, this was the regular expression. Now let me give you a very interesting, let me make them independent. Can I do that? See, if I just make the alphabet equal to 0 1 2, now notice what will happen. See, if I make the alphabet 0 1 2, now did I make them independent? Just just with help of this extra symbol, with help of this extra symbol, now I have made them independent. Now they are totally independent. Why they are totally independent? Because you can see, I can repeat this 0 1 now. Now I can repeat this 0 1 without 1 0. Notice what I will do. 0 1, then I will put 2, then 0 1, then I will put 2, then 0 1, then I will put 2. Okay, is this clear? Let me know. So can you notice that here I have how many 0 1? I have 3 0 1. And how many 1 0? There is no 1 0. Okay, is this clear? So what is this language? Tell me. Now they are independent. Okay, so you can see this variation. Did you understand this variation? Now they are independent. Okay, and this language is a non-regular. Did you like this variation? Now you have to remember how many 0 1 you have seen. Yes or no? You have to remember how many 0 1 you have seen so that you can match with 1 0. We have to remember how many 0 1 we have seen so that we can match with 1 0. So there are infinite possibilities of comparison. Okay, that's it. Understood? Please tell me. So this is non-regular. So you can see if I put these two, that's it. The language will become non-regular here. So this is a very nice variation. Let's see another variation. Here also, these two we have already seen that they were regular. Yes or no? Both were regular when your alphabet was 0, 1. Both of them were regular when your alphabet was 0, 1. Okay, now you tell me, if I make alphabet 0 1 2, if I make alphabet equal to 0 1 and 2, now tell me which of them will become non-regular? If I make, now what will happen? Now remember, I have made alphabet equal to 0 1 2. This number of 0 equal to number of 0, 1, this is still regular. This will still be regular. Why this will still be regular? This will still be regular क्योंकि why? Because already in this 0, 1 already 0 is there. This 2 cannot do anything. Array, just understand, this 2 cannot do anything. This 0, 1 already has 0. This 2 cannot do anything. This 0, 1, if this you repeat, let's assume 3 times or 4 times. Let's assume. Then already there is 0 4 times. If you repeat it 4 times, already the 0 has come 4 times. If you repeat this 0, 1 n times, then already n 0 have already come. So this 2 cannot do anything. Is this point clear? Please tell me. Let me know. So this is still regular. What will be the regular expression? What will be the regular expression? Because already 0, 1 is already there. Tell me what will be the regular expression. Your alphabet is 0, 1, 2. This is the alphabet. And we want number of zeros should be equal to number of 0, 1. Okay, just try to understand and tell me what is the regular expression. See, the regular expression is very simple. No extra 0 can come. Do you agree? In this language, no extra 0 can come. No extra 0 can come. If 0 comes, then it is part of 1, 0. Yes or no? If 0 comes, then it is part of 1, 0. Correct. If 0, every 0 is part of 1, 0. Can I say? Every 0 is a part of 0, 1. Every 0 is part of 0, 1. Okay, is this clear? So finally, what will be your regular expression? Your regular expression will be, remember, this 1 can repeat freely, 2 can repeat freely, 0 will come as a part of 0, 1 whole star. Okay, is this clear? This is the regular expression. 1 can repeat freely, 2 can repeat freely. This 0 is part of 0, 1. Okay, please tell me, did you understand this? This is the regular expression. So this language is regular. What about this one? Number of 0, 1, 1 equal to number of 1, 0, 1, 1, 0. And your alphabet is 0, 1, 2. Now this has become non-regular. Now this has become non-regular. Why? Tell me why this has become non-regular. Because now you can easily see with the help of this symbol, I can repeat these without the other. Okay, for example, what I can do, 0, 1, 1, then I can put a 2. Then again 0, 1, 1, then I can put a 2. Then I can put 0, 1, 1, then again I can put a 2. Then 0, 1, 1, like this. Okay, is this clear? So here you can notice how many 0, 1, 1 we have seen, that is 4. And how many 1, 1, 1, 0 we have seen, that is 0. Okay, is this clear? So now they have become independent. So this language is non-regular. Okay, understood? So that's it. These are all the variations that we have seen. I hope you understood. There is a GATE exam question based on this concept. This is GATE 2014 question. Okay, on this question you can see there are almost 28,000 views. Okay, and you can see there are 125 upvote. In this question they are asking which of them is regular, which of them is non-regular. Can you tell me immediately what is the answer? The alphabet is 0, 1, remember. The alphabet is binary. Can you tell me what will be the answer? Immediately tell me. So you can see W has at least as many occurrences of 110 as 011. So this is regular. L1 is regular, right? And L2 is non-regular. L1 is regular. L2 is non-regular. Because 00. Okay, so the answer for this question will be option A. Okay, is this clear? Please tell me. Let me tell you, for this GATE 2014 question, I have given the complete analysis in this video. Okay, this video you can find on the YouTube. This video you can see. This is GATE 2014 question. Okay, just search this video, or I will provide you the link in the description. I will provide you this 2014 question, the complete analysis of this 2014 question you can notice. Okay, this is, you can see 45 minutes video, because I have created DFA. I have created DFA for L1 because L1 is regular. So I have created DFA for L1. I have given the complete analysis of L1. Okay, L2 is already non-regular. Anyway, so this video solution you can watch it. I hope you got it. So this is GATE 2014 question. You can easily solve it. The detailed video solution you can find on YouTube. You can search it, or you can find the link in the description. Okay. Okay. Thank you everyone. Thank you so much. Did you enjoy this session? Let me know. In this session, we have done a lot of questions, a lot of gate questions, a lot of tricky questions. Okay. So I don't think that after this session you can ever make a mistake in finding regular or non-regular language. I promise you that after this session and after the previous session, okay, in these two sessions, whatever examples we have done, whatever tricky variations we have done, gate PYQ we have done, the formal method of checking regularity, non-regularity, the informal method also. So basically after we have seen every concept, now I think you are expert in finding if a language is regular or not. I've told you every variation. Let me tell you, no more variation are there on the internet. Also, I've collected the questions from many standard resources, from many, I can say from many resources. I've collected questions. And I've given you the complete analysis. Okay, so please tell me, are you confident now? Can you check regularity? This language is regular. This language is non-regular with formal method, informal method. Any variation they give you, any tricky question they give you. Please tell me, are you confident? Let me know. Okay. Thank you, everyone. Thank you so much. Please like this session and please put your feedback in the comments. Okay, your feedback matters. So please put a comment. Just put one comment. Please put your feedback in the comments. Okay. Thank you.